Have you ever heard of STEM? STEM stands for Science, Technology, Engineering, and Mathematics. These four subjects are important in the education world. So what's going on here? These days, the education world is facing the vast development of science and technology. Every individuals are expected to be able to overcome challenges of the 21st century critically and creatively. Therefore, STEM is needed to be introduced to students, teachers, as well as the society. So how do we reach this goal? STEM Village. Seeking, collaborating with the Center for Development and Empowerment for Teachers and Education Personnel, established STEM Village as part of their CSR program at Johor Village, Yogyakarta. The project was officially launched by the Ministry of Education of the Republic of Indonesia on 16 November 2018. With STEM Village, children experience hands-on activities which are joyful, useful, and practical. These activities aims to increase their motivation in learning mathematics. Besides children, this project also mentors parents to conduct STEM development activities in household levels. We believe that STEM is one of the cornerstones for success in global competition, and this is why we initiated this project.
The honorable prominent keynote speakers and moderators, Dr. Professor Edward M. Riff, Ms. Maria Suci Apriani, and Mr. Subhan Aziz Awaludin, and the honorable esteemed participants from Southeast Asia and beyond. Please welcome to the International Webinar Series 3 of Simeo Kitab in Mathematics, Preparing for a Post-Pandemic, Reshaping Future of Mathematics Education. Today, the 13th October 2021, via Zoom and Sikkim YouTube channel. My name is Hanifa Lupi. I will be the Master of Ceremony for this international webinar. To start today's program, I would like to invite everyone in this virtual room to listen to the Indonesia Raya National Anthem, continued by Simeo Colors and Simeo Winning Song.
Indonesia, tanah airku, tanah tumpah darahku. Di sanalah aku berdiri, jadi pandu ibuku.
Mathematics to deliver the welcome remarks and officially open the webinar. Dr. Sumardiono, the time is yours.
Thank you very much, Ms. Hanif Marufi. Honorable keynote speakers, honorable invited guests, distinguished participants, ladies and gentlemen, a very good morning. Assalamualaikum warahmatullahi wabarakatuh. On behalf of the Siamio Regional Center for Kitab in Mathematics, or SIKIMS, it is a great pleasure for me to welcome you to our third international webinar in this year 2021. In the theme, preparing for a post-pandemic, reshaping the future of mathematics education. Thank you for taking the time to attend this event. In this priceless moment, I'd like to extend my deep appreciation to the distinguished keynote speakers, Dr. Scott Bartholomew from School of Technology, Brigham Young University, United States of America, Professor Trina Wilkerson from National Council of Teachers Mathematics USA, and also Associate Professor Jagu Singh Dinyal from National Institute of Education, Singapore. My most profound appreciation also goes to today's moderators, Dr. Edward Reeve from STEM 8, Thailand, Ms. Maria Suci Apriani from Sanata Dharma University, Indonesia, and also Mr. Suban Aziz Awaludin from Hamka University, Indonesia. Ladies and gentlemen, I'm pleased to inform you that SIKIM successfully has conducted 2 international webinars in March and June 2021. It was participated by more than 1,000 participants from several countries worldwide. Therefore, the Center would like to thank all mathematics teachers and educators in Southeast Asia and beyond, Siamio sister centers, and also stakeholders for their endless support. Ladies and gentlemen, the world has fought the pandemic of COVID-19 since 2020, and no one can predict when the pandemic is over. During the pandemic, many sectors are affected, including the education sector. The challenge for teachers now are how to face and overcome the loss of students' learning, because we realized that during the pandemic, the teaching and learning process, particularly in mathematics education, isn't easy to teachers and also students. However, the challenge and obstacles, we have to prepare for a better future of mathematics education after this pandemic ends. Here we are right now. Today, our keynote speakers will deliver and discuss the preparing for a post-pandemic, reshaping the future of mathematics education. Ladies and gentlemen, as of yesterday, more than 400 registrants from Southeast Asia and beyond have registered for this event. We are still waiting and welcoming for other participants to join us in this webinar. And finally, I declare the international webinar, Preparing for Post-Pandemic, Reshaping the Future of Mathematics Education, officially open. We wish you all a fruitful webinar. Stay safe, stay healthy, and stay connected with SIKIM. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Ladies and gentlemen, the official opening by Director of Simeo Kirab in Mathematics marks the preparing for a post-pandemic, reshaping the future of mathematics education has started. Thank you very much to everyone for attending the opening ceremony, and we will proceed to the keynote address sessions. But before that, let me read the webinar protocol. First, the webinar is recorded. Second, participants other than keynote speakers are muted. The third, participants joining from Zoom and YouTube should fill in the attendance list through the link provided in the Zoom chat box and YouTube description. And the fourth, in the end of the webinar, participants should fill in the evaluation form provided in the Zoom chat box and YouTube description. Kindly check on the Zoom chat box and YouTube description regularly. And the fifth, a certificate will be provided for eligible participants. So please make sure that you join the whole program to be the eligible one. And another protocol is for joining the Q&A session. The first, each keynote speaker will present for 40 minutes, followed by 20 minutes Q&A. Second, for participants joining from Zoom, participants may leave their question on the chat box, and selected one participant will be given a chance to ask questions directly. For participants joining from YouTube, participants may leave their question on the link provided in the YouTube description. Thank you, and that was the webinar protocol. Ladies and gentlemen, I am pleased to inform you that the committee has prepared the giveaway for the lucky winners for all participants who join us today. Here is the easy ways to join our giveaway. Number one, follow Sikkim Instagram at @CMEO-KIDAP-INMET. Number two, capture the webinar by taking screenshot or recording. And number three, upload them to your Instagram story and mention us at @CMEO-KIDAP-INMET, and the winners will be announced to Sikkim Instagram feed. Well, we are now proceed to the keynote address one. We will have the keynote speakers from School of Technology, Brigham Young University, USA, Dr. Scott Bartholomew, and his session will be chaired by Professor Edward M. Reeve from CMEO STEM Ed, Thailand. Professor Edward M. Reeves is a professor emeritus and former teachers educators in the area of technology and engineering education, or TEE, from the Department of Applied Science, Technology, and Education at Utah State University. In his career, he worked to advance knowledge in the field of technology and engineering education and career and technical education, or CTE. His professional interests, research, and numerous publications and presentations have been in areas related to educational standards, curriculum development in science, technology, engineering, and mathematics, or STEM education, competencies-based education, and improving teaching and learning. Good morning, Professor Edward M. Reeves.
Selamat pagi.
Selamat pagi.
Good morning. Where I'm in, it's actually evening, so good evening. It's evening here in northern Utah.
Oh, sorry, good evening, Professor.
That's all right.
So, Professor, the time is yours.
Well, thank you. And I'd like to introduce our keynote speaker right now is Dr. Scott Bartholomew. Dr. Scott Bartholomew has been a professor and teach educator at Purdue University and now is at Brigham Young University. Dr. Bartholomew was actually my student. I was his PhD advisor, and he was one of my best students, I might say that. So I'll say that. Dr. Bartholomew joined the faculty at Brigham Young in 2020. earned his bachelor's and master's in technology and engineering at Brigham Young University. And he also taught middle school and engineering classes in Alpine School District before getting his PhD at Utah State University. He then took a job at Purdue University and was a professor there. He's actively involved in local and national professional organizations and has spent a couple years doing a service mission in the Philippines, where he really enjoyed it. So without much further introduction, I'm going to turn it over to Scott. So Scott, it's yours.
Thank you, Dr. Reeve. It's wonderful to see you. And thank you, everyone else. I am so excited to be here. As Dr. Reeve mentioned, I have a great connection and love for Asia and the wonderful people that are there. So I'm going to share my screen and let's get started. So today I want to talk a little bit about reshaping the future of mathematics education, but specifically through STEM. And I want to share a few ideas with you. But before we start, I want to tell you a little bit about who I am. I appreciate the introduction from Dr. Reeve, and I'll just fill in a little bit more. As he mentioned, I lived in the Philippines for 2 years as a service missionary. I saw in the chat that there's a lot of Filipinos here. So magandang umaga sa inyo. Gabi dito sa amin, pero magandang umaga sa inyo. I loved living in the Philippines. I lived in many different places, but mostly I was up in northern Luzon in Cagayan Valley and Ilocos Norte. After I returned from the Philippines, I did my schooling, as Dr. Reeve mentioned, and was a middle school teacher and a professor. And I have some pictures there of my family as well. So my wife's name is Julie, and we have 4 kids. My oldest is 9. And then I have a 7-year-old, and then a 3-year-old, and then a 1-year-old. And it is their bedtime. So they are upstairs. Hopefully they're going to bed right now. I don't know if they are or not. But as Dr. Reeve mentioned, it's nighttime here for us. So, but let's talk a little bit about what STEM education is. And for this keynote, I'm going to try something a little bit different. I realize many of you are watching this on YouTube or maybe streaming this. And some of you might watch this after the fact, but I'm going to try something a little bit different. And for this keynote address, I want you to have some supplies. Okay, I want you to have a few things because we're going to try a couple things together here. I want you to have some scissors, some tape, some paper, some utensils, a fork and a spoon. You'll need a cell phone, and then a few other random items. And we'll talk about what you're going to do with those in a little bit. But if you don't have those right now, I want you to try and get as many of those as you can right now so that you can use them in just a minute. Okay. So scissors, tape, paper, utensils, cell phone, and some other random items. Okay, I'm going to ask that you have those and try and grab those, and we'll do a few things with those a little bit later. Okay, so let's first talk. What is STEM education? As was mentioned, we're just in the middle of the COVID-19 pandemic, and no one knows when it's going to end. But this I do know. STEM education is something that we can do even in the middle of the COVID-19 pandemic. This is something that we can do, and we can do it well, and it will help our students to learn and grow. So STEM education, let's just have a definition here. STEM education is a teaching and learning approach which emphasizes the connections among or the integration of knowledge and skills in science, technology, engineering, and mathematics to address problems facing our communities. So let's break that down just a little bit more. I see STEM education as making connections and solving problems. Okay, if we look at that definition again, and this is from Simeo, we talk about connections and we talk about problems. And so if we make that even a little more simple, we could say that STEM education is all about making connections while solving problems. Okay, and I believe that that's what STEM education is. If we can help our students to solve problems and make connections while they're doing it between science and technology and engineering and math, then we are doing STEM education. So let me give you an example. Here's one example of a STEM problem. Okay, this is one that I just thought of. Okay, so STEM problem. There's an invasive species of insect that has killed the local bamboo trees. However, you relied on the bamboo to produce back scratchers, which were sold at the local market. Okay, so that's a problem. That's just a common problem that your students might have. Okay, when I was in the Philippines, I remember seeing bamboo all over the place, and I remember seeing back scratchers just like these when I'd go to the market in the Philippines or to the palenque. Okay, so here's the challenge for our students. We don't have any more bamboo. We can't build back scratchers. So can we find a new way to build a back scratcher without using any bamboo? So that's the challenge. We have a problem, and that leads us to a challenge. Now there's some rules, or there's what we call in engineering criteria and constraints. These are limits on what we would be able to do in this particular STEM problem. And so one limit is your design must use only natural or available materials. Okay, you can only use what you have around you. Okay? And this is an important one, especially during COVID, because if I was teaching my students through Zoom, they may not have access to all the materials that I have in the classroom. And so we need them to only use the materials that they have with them. Okay, rule number 2, or criterion constraint number 2. Your design must be easily replicable. So if we make one, we need to be able to make another one as well. Okay. Rule number 3, your design must follow the proper ratio. Okay. Now we're getting into some math. Okay. This is good. We're speaking to math teachers. This is good. If you look at the image, the standard ratio of a back scratcher is that the handle is 80% of the overall back scratcher. And then the end, or the piece that you use to scratch your back, is 20%. So we have 80% and then we have 20%. Okay, there's a ratio there, and we could tell our students, you need to follow the proper ratio on your back scratcher. Okay, and then look at the bottom, we've got some connections. Okay, as we did a challenge like this with our students, we could talk about materials, which is engineering. We could talk about levers. Okay, that's some science and some engineering principles there. We could talk about troubleshooting. That's a general STEM principle. Okay. We could also talk about ratios. Okay. Now we're getting into some math. We could tell our students, what does it mean to have 80% and 20%? Well, if my overall back scratcher is 0.5 meter long, well, then how long should the handle be? Or how long should the end be? And this gives us an opportunity to bring some ratios into play. Okay. And so now I want to try something different, something that maybe you've never seen in a keynote before. Okay. I want those of you that are watching, I want you to try it right now. Okay. And I'm going to try it too. I brought a bunch of random supplies, just things I grabbed from around my house. And I'm going to try and build a back scratcher right now as well. This is something I haven't done before, but I want to show you that this is something that we can do. Okay, this is something that our students can do, and this is a way that we can do STEM with our students and do STEM together. So here's what I want you to do. Hani, can you put up on the screen the Instagram handle for Simio again? I want those of you that are watching this at home, I want you to build a back scratcher, take a picture of it, and put it on that Instagram. Okay, post it with the hashtag of the Simio Instagram account. And Hani, I didn't tell you I was going to do this, so I hope this is okay. All right. And what we're going to do, and I'm going to build one right now as well. And this will give us a chance. We can take a look and see at what some of the things that you've built are. So let me share my screen, and maybe we can just do this. Let's put the Instagram handle in the chat. Let's just put it in the chat. And then people that are building these can use that handle to tag their posts that they do. Okay. So I'm going to share my screen again, and I'm going to go ahead and build this, and we'll talk this through like we would as if we were doing this with our students. Okay. So let me go ahead and share. All right. So remember, we're trying to build a back scratcher, and I've got a bunch of random supplies here. These are just things I grabbed around my house, okay, that I might use to complete this challenge, okay, that I might use with my students. Remember, in our back scratcher, we need the handle of the back scratcher to be 80%, and then the end of it is going to be 20%. So I'm going to look at these supplies, these random supplies I brought from my house, and I'm going to try and think what I might use to build a back scratcher. And I think right off the bat, this could work well. I could use this for a good handle, okay? And hopefully those of you that are watching this at home, you're building your own back scratcher right now. I want you guys to try and build your own back scratcher. Post a picture on Instagram with that handle so we can see all those back scratchers, okay? I think what I'm gonna use is I'm actually gonna come in here. All right, and I'm gonna use something like this, okay? So I'm building this back scratcher, and this is something that we could do with our students, okay? Even if we are remote, okay? So this is an activity that our students could do even if they are remote. Obviously, if we're in the classroom, okay, that might be even better, right? We would have opportunities to have discussions with our students and things like that, but this is also something that you could do with your students and a challenge you could give them, and they could work on at home, just like I have asked you to work on this as well. Okay, and all my Filipino friends, kaya nyo yan. Kaya nyo ito, huh? This is going to be great. Okay, we're going to build us a back scratcher out of just random supplies. But remember, the mathematic principle that we're trying to teach here is we've got to look at some ratios. Okay, so I've got my little back scratcher here. Okay, something like this. Now, okay, I think this would work. I think I could use this for back scratcher, but I don't think my ratio is correct yet. So what I'm going to do now is I'm going to pay attention to the criterion constraints. Okay, and I'm going to go ahead and check my ratio here. Now, I'm in the United States here, so this is in inches, but if you look down at the bottom, we can see our centimeters, okay? So my handle on this back scratcher, okay, is 20, looks like 22 centimeters, okay? And then this final portion, okay, is 3 centimeters, okay? So what I could do is I could come in here and I could say, well, I got to do some math, you know, if my total is 26 inches or 26 centimeters long, my handle is 23, okay? If I do 23 divided by 26, the overall distance to get a ratio here, that means that my handle right now is actually at 88% of my back scratcher, okay? Oh, so then I could come down and I could make some adjustments here, okay? I could move this handle down a little bit so that I get it to the exact right spot where I'm now at 80% and 20%. But this would give me an opportunity to work with my students and talk about, okay, what are ratios? Well, how did I figure out what ratio or what percentage this part of my back scratcher was as opposed to this part of my back scratcher, you know? And I did 26 divided by 23, and that gave me my ratio there. But this is an activity, a very small STEM activity where we have a problem. The problem is we don't have any back scratchers, okay? Which gives our students a challenge, which then gives us an opportunity to make connections, okay? So as we solve the problem with our students, we help them make connections between science, technology, engineering, and math. Okay, I'm going to come right here. I'm going to actually demonstrate my little back scratcher here. I think it works pretty well. I think Dr. Reeve wishes that he had one of these right now. He could use one of these back scratchers, okay? So this is just a simple idea, a simple example, okay? of one STEM activity that you could use with your students, okay, right now. Now, Hani, thank you for putting that in the chat window. Thank you. So you can see the Instagram handle is in there. Go ahead and take a picture of your back scratcher that you created, okay, and post it onto Instagram, okay? And I'm excited to get on and see all the different creations that everyone's made. Let's talk a little bit more about what STEM means, okay? So we talked about this STEM problem, and remember, very simple problem, we made a back scratcher, okay? But the key to using STEM problems, or the key to taking mathematics education and moving it forward through STEM, is to make those connections. I could have my students build a back scratcher, and that would be a fun activity. You know, they might have a good time, but the learning happens when my students make the connections. We can talk about materials. Well, why do we use bamboo to make a back scratcher? What other materials are like bamboo? And that would be some engineering. We talk about levers. You know, why does a back scratcher work? When I'm applying pressure on the handle, why does that apply pressure to my back? Well, let's talk about the science or the engineering there. Okay. And I talked about ratios. Okay. We could figure out, well, if you make a back scratcher that is 25 centimeters long, well, how long should your handle be, and how long should the scratch part be at the end? Let's talk about ratios and how to figure out what ratios are. And this gives us an opportunity to teach our students, even if we're over Zoom or in person, okay, we can teach them through STEM. So let me give you a few more examples. These are examples that I used with my students during the pandemic, okay? So pandemic, no one's in class, we can't get together, everything's over Zoom. I thought, oh no, my students are going to be tired and bored, and it's going to be so difficult. What can we do? So here's one example. The local mall has an amusement park ride, but the roller coaster customers have complained about. They believe it's too fast. So I told my students, can you design a roller coaster that takes at least 30 seconds to complete? There has to be times when it's slow, and there has to be times when it's fast. The roller coaster must be made with nothing but paper and tape. Only paper and tape. And I did that because my students were at their house and I didn't know what supplies they had. But I knew that all of my students had paper and tape. The roller coaster also had to be safe and demonstrate two instances of potential and kinetic energy. Okay, so you can see I brought some science in there. We've got energy, potential and kinetic, which is a science principle, speed and mass, that's another science idea, distance, fractions, ratios, and formulas, that's math. Okay, you can see this picture on the side of one that my students made. Okay, I asked them to tell me the ratios on the height, how tall each roller coaster was and how fast it went. Hey, and we talked about Newton's laws. Okay, that's engineering and technology. Well, let me show you what one of my students did.
Hazel solemnly. Hazel smiled and ruffled her hair. That's a good thing to be, Julia. Hello, Frank said. Would be good too. Hazel said. Which was lit up with multicolored lights.
Hey, isn't that pretty amazing? I thought that was pretty amazing. I was really proud of my student and what he put together there. Okay, but this is an example of giving them a problem. The problem is we need a roller coaster that takes a certain amount of time. Okay, and then helping them make connections between all the different areas of STEM. Okay, let me show you just one more example here. Okay, this is one that happened in the Philippines all the time. In the Philippines, I would be out. And I lived more out in the provinces, a little bit away from the city. And so we would walk a lot on the roads. And all the time, there would be lots of people working in the field, but only one vehicle. Okay. This vehicle right here that I have a picture of is called a kuliglig. It's one of my very favorites. Okay. And in the Philippines, they have a saying. Isa pa or kasha pa. There's room for one more, right? And they would just put more and more and more people on these vehicles that they had. I've seen this when I was in Thailand. There would be a motorcycle with one driver, and then they would put another, and then another. We can always fit one more, and this is a great thing. Okay, so I gave my students a challenge. I said, can you build a chair that holds 3 cans of food? Okay, 3 cans of food. But you can only use 3 pieces of paper and a 1/2 meter of tape. That's all. Okay. Once again, this was during COVID. My students were at home, so I didn't know what they had, but I knew that I wanted to keep teaching them these STEM ideas. And so I had to come up with a challenge. So I told them a story about when I lived in the Philippines and I got to ride on these kuligligs. Okay. And I said, one of the things that we need to do is your challenge is to make a chair. You need to make a chair that can hold 3 cans of food, and you can only use paper. That's it, nothing else. You can see some of my connections there. We talked about size, area, and volume. Okay. You can see in that picture from my student, his chair has some cylinders. We talked about volume and surface area and why, what might be the strength of different volumes or different surface areas. Okay. We talked about tension and compression, which are science and engineering terms. And then we talked about adhesives, okay, because you can use tape technology. Let me show you what one of my students did for this challenge. 3 pieces of paper, that was all. This student actually did it with only 1 piece of paper, okay, and 1/2 meter of tape. Let's go ahead and watch.
All right, here we go. We have one 19-ounce can already on. Adding another one. Another one. Another one. Adding another one. I know that's 1, 2, 3, 4, 5, 6 cans currently on. Seven cans currently on. I'm running out of cans. 1, 2, 3, 4, 5. 7 Progresso chicken noodle soup cans plus 5 chunk. Okay, we're gonna go 2 light chunk tuna cans. And it stands. All right. Another chicken noodle soup can. Just grab another Progresso can. The 5th chunk light tuna can added. Dad, look at this. Adding a 8th Progresso can. I can get it to balance. And it did not hold the 8th can. I got it. Stop going. All right.
Hey, what do you guys think? Pretty good. I thought that was great as well. This is another, okay. So after we did this challenge, able to talk to the students and say, all right, okay, tell me the volume of the cylinders that you used, or the surface area, or the size, and how did it change? You know, what are some of the things we can learn about this? These are some simple examples that I did during STEM or during the pandemic, because we were all, you know, stuck at home. But these are examples that you can do in the pandemic or outside of the pandemic. Okay, simple problems that allow us to teach our students principles of science, technology, engineering, and math. Okay, and help them remember, make connections while solving problems. So I want to teach you today what I call Dr. B's smart approach to STEM. So my name is Scott Bartholomew, and my last name is kind of hard to say, Bartholomew. Okay, in the Philippines, all my students call me Dr. B. Approach to STEM education. So the S stands for start with a problem part. The M stands for make it fun. Okay, masaya, make it fun. What can we do to make this fun? I could have told my students, I want you to do a worksheet with a whole bunch of problems about ratios. But that's not very fun. Fun to design a back scratcher. I could worksheet on surface area or on volume, but that's not very fun. It's much more fun to build a chair and see how many cans of food you can hold. So let's make it fun. Okay, the A stands for active learning. We need to get our students doing things. Okay, they've got to be active. The R stands for real. Okay, or tunai. Okay, we've got to use something that's real. What's a real challenge? Something that the students can relate to. Okay, if your students are familiar with bamboo because they have bamboo around their house, then that's a great challenge because it's something that's real. Okay, and then the T stands for technology. Okay, what can we have our students do with technology? Maybe we're going to use Facebook Messenger or Instagram or WhatsApp to integrate our lessons. Let's use technology. So let's talk a little bit about this. Okay, remember number one, the S is start with a problem. Okay, so if you remember my bamboo challenge that I gave you with the back scratcher, we started with a problem. Okay, they had to build or design a new back scratcher because they didn't have any more bamboo. So I started with a problem. And problems always lead to a challenge or an opportunity for our students to do something. Remember what we talked about earlier, okay? This needs to be active. We need to engage our students in something. They've got to do something. So problems lead to challenges, okay? And in my field, which is technology and engineering, we often call these design challenges. I recognize that for most of you, you're teaching math. And so maybe you don't call it a design challenge, but you just call it a challenge. Okay, this is the problem, and here's your challenge as a student. You need to try and solve it. Okay, challenges always have criteria and constraints. What does that mean? Well, the criteria and the constraints, these are the rules. So if I want my students to design a new roller coaster using only paper and tape, I've got to give them some rules. How many pieces of paper? How big do I want it to be, or how small? How fast do I want the roller coaster to go? How much tape can they use? These are all the rules. And in engineering, we call those criteria and constraints. So problems lead to challenges. Challenges lead to criteria and constraints. And then the criteria and constraints, well, everything together leads us to connections. It's not a good STEM problem if we don't help the students make connections. So if we're designing roller coasters or if we're designing back scratchers, okay, there's always connections that we can make between science, technology, engineering, and math. And it's our job as the teacher to help the students make those connections. So I could have designed a back scratcher, and that would have been fun. And maybe I had some rules, but it wasn't good STEM education until I helped make the connection between the back scratcher and the ratio. So if I help my students understand, okay, this is the ratio and here's how you figure it out, now that's a good STEM problem, okay? So that was the S. Remember, the S is start with a problem. Okay. The M is make it fun. Okay. What can we do to make our learning fun? So this is a screenshot of my class during the pandemic. Okay. My students hated learning online. They hated getting onto Zoom. They would turn off their cameras. And I would ask them questions and no one would answer, and they just didn't like it. So I tried to do some things to make it fun. And here's one example. One day I told my students, I said, okay, today is hat day. During class, everyone's going to wear a hat. You can wear whatever hat you want. And that was one way that I tried to make my class fun. We still did all the same things. You can see my picture right down here in the corner. I even wore my hat, okay? What can we do to make it fun? If we're in person, let's do some hands-on learning. If we're on Zoom, Maybe we have a hat day, or maybe we do something else, but what can we do to make it fun? Okay. The A is active learning. Okay. Active learning. So here's an example of active learning. Teachers need a way to hold their phone while they're video conferencing with students that allows them to use their hands to show what they're doing. So remember, problems lead to challenges. Design something to turn your mobile phone into a document camera so that you can show your hands to your students. Okay. There's always criterion constraints. The device has to hold the phone a certain distance up. It needs to be easy to add or remove the phone. It needs to be made from readily available materials. And then you can see I have a list of connections. Okay, engineering, design and drafting, science or math, structures and forces, technology, simple machines, criterion constraints, technology, engineering, and troubleshooting STEM. So this is another example of an active learning. You can see that picture there. This is a different design challenge. And I actually did this design challenge with teachers in Cebu. Okay. So these are all my Filipino friends. These are all teachers. Maybe I have some of these teachers on this webinar. I don't know. Okay. But we did an active design challenge where we had some water and some materials like rock and salt, or rock and sand and other things like that. And they had to design a system to slow down the flow of water. It was active. They were using their hands. And we did this design challenge at a conference. So we're at this fancy hotel with all this conference, and I brought in all these materials and we had a great time. Okay. Make your learning active. What can you do to have your students use their hands, to engage, to do different things? Okay. All right. The R. The R is for real, or in Tagalog, you say tunay. Okay. Or they might say hindi peke. It's not fake. Okay. We need to do things with our students that are real. So they need to see a connection between life and the assignment. And this becomes even more important as we're coming out of this pandemic and moving forward. Let me give you an example of a real challenge that I think would be so fun to use with students in the classroom. When I was in the Philippines, it was very common. I would be walking down the road and I could look to the side of the road, and on the tin roof of the houses, there was all these fish. And these fish were drying on the roof because the sun was so hot, it would dry the fish. They called it tuyo, okay? Or dry, right? So the fish are drying on the roof. Well, maybe we can turn this into a STEM challenge, okay? A common practice for drying fish involves placing them on the roof. But sometimes if they're on the roof, you might have birds or insects or other problems that might make it so that these fish are not clean anymore, or they're not good to eat. So can we design a new way to dry fish? You know, I put in there bongos because that was my favorite fish when I was in the Philippines. I also like tilapia. That was a good fish as well. But can we design a new way to dry fish? This is a challenge we could give to our students that they could do at home. Can they build something to dry fish? Remember, criterion constraints. They can only use things at their house. They can't use anything else. So they're going to use bamboo and maybe they're going to use some paper and some tape and they're going to build something, okay? The fish must dry before it goes rotten, okay? And that's, we could give that constraint and our students could actually build it and test it. Now, remember the connections. We could talk about the anatomy of a fish with science. We could talk about the drying process. So what happens as a fish dries, which would be science and engineering. We could have them, sketch their design, some technology or engineering. Talk about food quality and what that means. We could also, okay, we could talk about the length of time it takes a fish to dry. If it's a big fish, does it take more time than a smaller fish? That gets us into ratios, and maybe our students could graph those, and we could write formulas with variables for the amount of time it would take a fish to dry. Hey, that's a great way we could bring math into a real problem that our students are working on. Okay. All right. Let's talk about the T. The T stands for technology. Okay. Here's another problem. And this is a picture of a project I did with my students during the pandemic. Okay. your city park, okay, or in the Philippines, your barangay, okay, is flooded every year during rainy season. Okay, I remember when I lived in the Philippines, we would walk around the city and there were certain neighborhoods or barangays where when it would rain really, really hard during the rainy season or tagulan, it would just flood everything. And sometimes there would be so much water, it would kill some of the plants. So this was a challenge I gave my students where they had to use technology, okay? So what they did is I gave them partners. So they had 4 people in a group, and they had to work on this challenge outside of school. And so what they would do is they would talk to their partners on WhatsApp. Okay, they would use their phone to talk to their partners, and each person had to design one piece of this bigger design that they were going to build, this bigger park that they were building together. So everyone had to design one piece, but they had to talk to each other. They had to use technology, or the pieces wouldn't fit together. So you can see right up here where the students' hands are. This piece and this piece didn't fit together because they didn't use technology well to talk with each other as they were designing. So that's a criterion constraint. That's one way we could use technology. Once again, let's look at the connections. STEM is solving problems and making connections, right? So drafting, they had to draw things out, is technology and engineering. Hey, they were building something. They're actually making it. That's engineering, structures. We talked about water flow rates. So how fast does water flow and where does it stop? That's science. And then graphing in distances. How far does the water go? Where do we need to build things? That's how we bring the math into play, okay? So remember, STEM education is making connections while solving a problem. And putting math into STEM education is one of the ways that we're going to reshape the future of mathematics as we move forward, okay? So now I have a question for you, and I want to use the chat in Zoom, okay? So I'm going to ask all of you to put an answer in the chat window. What problems could you use in your class? What problems can you think of? Here's a few pictures that I took when I was in the Philippines. So this first picture, you can see we have these 2 individuals and they have this animal riding on their motorcycle, okay? So is that a good STEM problem? I think so. I bet we can make some connections. Here's another one. Hey, in the Philippines, it's very common for everyone to leave their sandals outside the door. But the problem is, as I was walking in the door, I would sometimes trip on all these sandals. Well, that's a good STEM problem. Hey, who's seen this in their city? This is very common. All the wires for electricity going together. Maybe we can come up, maybe that's a good STEM problem. Or flooding in the streets, okay? What can we do to solve the flooding in the streets? These are good STEM problems. So here's the question I have. What are some real problems that your students might see that could be used to engage them in STEM? Problem solving with connections. So I want everyone to add your ideas to the chat. I'm going to stop sharing my screen so that I can see the chat. And I want to take a few minutes and we're going to let you put your ideas in the chat window in Zoom, and then we'll talk about them, okay? So I'll be quiet and I'll let everybody, let's put your ideas in the chat window. What ideas do you have for some good STEM problems? All right, I'm excited to see some of these ideas come in. Who has some ideas? Go ahead and put them in the chat window for us. Oh, that's an interesting idea. The reproduction of a lizard. I like that. Good idea, Tommy. Oh, Deanne says home design. I think that's a great STEM problem. And you could maybe make it a little bit smaller and you could have them design one part of a home or one room in a home. But I think that's a great idea. Thank you. Anyone else have any ideas? Ah, the messy bedroom. Okay, how to clean up a bedroom. That's a good one, especially if our students are learning from home, right? Oh, Adinda has a great idea, preventing ants from eating food. Ah, I love that. Can you design something to keep the ants from eating your food? That's a wonderful idea. Okay. All right. How lizards breathe, or the respiration of a lizard. That's a really good one. Very good. Anyone else have any ideas? We probably have maybe a couple more minutes for any other ideas to come through. I also like in Ninook's idea with the messy bedroom, pointed out the connections, right? You know, classifying the items in the bedroom could be tied to math. The decorating of the room could be a design problem. You know, so these are some great ideas. And if you think about the preventing ants from eating food, we could learn about ants and what they like to eat. That would be science. Okay. We could do an exercise where we figured out how big the ants are or how many there are. And that could be something with math. And then our tech and engineering or technology and engineering could be the design problem. Okay. All right. A couple more have come in. A system for students to hand in their homework. That's a great idea. Could they come up with a new way to hand in homework? Or here's another one. The things on the table are all messy. Or another one came in, a new spoon for a small baby, okay, a 1-year-old baby. I would like that. I have a 1-year-old. I need a new spoon for the baby. That would be a great idea. Okay. Pearl just put another one in there. How to use a string and pencil to represent the slope of a line. Ah, this is great. Now we got a whole bunch of good ideas. Okay. A solar oven. Okay. These are great ideas. All right. Now I can see my time is getting short. So I want to just share a couple more things with you really quickly. Okay. Remember, just in review, okay, Dr. B's SMART approach to STEM. S, start with a problem. Okay. M, let's make it fun. A, let's make it active. Let's have our students do something or build something. Okay. R is real. It needs to be something that connects to their life, something real. Okay. And then the T is technology. Can we use technology to help our students to learn something that maybe they wouldn't be able to learn otherwise? Okay. So the key is to have all the different parts of the problem. Okay. Start with a problem, make it fun. Let's have it be active, something that we're doing together. Let's have it be real, and let's use technology. I so appreciate the time today and you letting me present to you and talk to you a little bit about what I think STEM education is. These are some of my pictures from when I was in different places in Asia. Okay, the one on the left is when I was in Thailand. Okay, the one on the right is actually in the Philippines, in the most beautiful place in the entire world. Is in the Philippines. It's a place called Palawan. Okay. At this point, I think it's time for us to go to some questions. So I'll stop sharing my screen. And I believe I'll turn the time back over to Dr. Reeve.
Scott Termakashi. Thank you. And So again, thank you for your fine presentation. I'm going to share my screen here and kind of summarize this and have some questions for you.
Okay.
Okay. Okay, sharing my screen here. This is questions for our keynote speaker. I want to remind the group that Scott defines STEM education as a teaching and learning approach which emphasizes the connections among or the integration of knowledge and skills in science, technology, engineering, and mathematics to address problems facing our communities. That has been STEM defined by the CMEO STEM Ed Center, which I am also a specialist for. Scott talked about approach to STEM, the SMART approach. Start with a problem, make it fun, active learning, make it real, and the use of technology. I want to remind all of you that the components of STEM, and many of you are math teachers, so it's important that you understand the components of STEM, that science involves the investigation and understanding of the natural world. The bamboo, the fish, those are examples of science. Technology is modification of the natural environment through human designed products, systems to satisfy human needs and wants. Your smartphone, your computer, those are all technology. Engineering is the use of scientific principles and mathematics reasoning to optimize technologies in order to meet the needs that have been defined by criteria under constraints. And I want to remind you that engineers create technology. And finally, for you math people, math, I believe, is what ties STEM together. We often forget about math, but without math, STEM does not exist. Mathematics enables communication and critical analysis and how we make sense of the human and natural world using numbers and computational reasoning. And Scott showed that. These definitions came from our standards for technology, technological, and engineering literacy. And Scott was involved in the writing of these standards. And these standards are free from the ITEEA website. So these are the components of STEM. So those involved in math should understand the components of STEM. Scott gave an activity for us. He talked about STEM again as making connections while solving problems. He gave you a problem to build a back scratcher. He showed you these connections. So now we'll go with the questions that were asked, a few of them, and then we'll have a live question. So question number one, STEM, or Scott, in making STEM connections, must we have all the elements, problems, challenge, criteria, constraints, and connections? So there's your first question.
I thank you. This is a wonderful question. I think the short answer is no. However, I think if you can have all of the elements, it will make the STEM connection easier for the students. For example, if I give my students a problem, if I say, I can't reach the mango on the tree, but there's no challenge or there's no rules or any connections after that, my students might learn about the tree and the mango, which would be some good science. And maybe they would even do some math. They might say, well, how, if I do a Pythagorean's theorem, how tall is that? But if I can give it to them as a problem with a challenge, with criteria and connections, it makes it easier for the students to tie all of STEM together, to bring it together. Remember, STEM is solving problems and making connections. And so our job as the teacher, at least I believe, is to help them do that by having a problem, a challenge, criterion, constraints, and then the connections. Great question.
Thank you, Scott. I will go to our next question here. How do we create activities where the students are more active in learning?
This is a really good question, because this was really, really hard during the pandemic. All of our students went home and we didn't have them in the classroom. And this was something that I really struggled with. I said, So I teach technology and engineering, and I have in my lab, I have, equipment and materials, and my students didn't have that anymore. And so I think our job as a teacher is to be really creative, but this is the suggestion I have. Don't find big problems. Find very small problems. And those are the ones to use with your students. Because if we tell our students, you need to clean all the ocean, that problem is too big. They can't do that. That's not something that they're able to figure out. But if we tell our students, so here's an example. When I lived in the Philippines, there was a little lizard called the butiki, and it would run around on the ceiling and it would make very loud noises at night and wake me up. That's a small problem. That's a problem that our students can solve. So find small problems and then give them to the students for an opportunity to be active in their learning. And because it's small and it's something that's real, they'll have a chance to interact with it as part of their life. Great question.
Thank you, Scott. I'll do one more question, then we'll go to a live question. So
Okay.
question number 3, Dr. B, what should we do to find an idea and create STEM learning for our students? Sometimes it is hard to find an idea with SMART criteria, as you show us.
That is true. It is hard. Coming up with the SMART criteria can be very difficult. And this is my suggestion. The next time you get on the bus, or if you're in the Philippines, maybe you're on a jeepney, or if you're on Thailand, I think they're called tuk-tuk. Is that right?
Tuk-tuk, yeah, that's right.
Tuk-tuk. Okay. The next time you get on one of those, just look around. What are things that people are doing to try and make life easier? People do all sorts of things to make life easier. Every single thing that someone does to make life easier is a problem that you can use for STEM. Okay. So here's one example. In the Philippines, when you get on a jeepney, it's a big Jeep that you ride on, one of the things they do is there's someone on the jeepney that takes the money. You have to pay the money to get on and off. And because this person is taking money, they're always trying to give money to passengers and take money from passengers. And they have to remember who has paid and who hasn't paid. And so they do all sorts of things. They put the money between their fingers, or they start at the back and go to the front. That's an example of a STEM problem. Can we create something that would make that easier? So the next time you are out in a tuk-tuk or a jeepney or a bus, look around and say, okay, what are people doing to make life easier? And those are problems that you can start with in STEM.
Again, Scott Teramakashi, thank you. You see me, I'm right there. That picture actually is my backyard today. We had lots of snow here where I live. A problem was that the snow, the leaves made it very heavy, the weight, and a lot of the branches broke. So there's a STEM problem to solve.
That's a great
So
example.
I'm going to stop sharing here in a minute, but we do have a Ms. Weirda Diana will ask directly to Dr. Scott. So I'm going to stop sharing, and Ms. Weirda will ask you a question. So I'll stop sharing, and she wants to ask you live, okay? So we have a live question, I believe, coming up.
Hello, good morning.
Good morning or good evening.
Okay, doctor. Actually, in making STEM activities, is it we must have all the element of science, technology, engineering, and mathematics, or we can skip one, or just choose that one element that relate?
That's a very good question. The answer is no, you don't have to have all of them. However, I think most problems you can use all of them, but what will happen is you will have a focus. So maybe your STEM problem has lots of science and a little bit of technology and engineering and lots of math, or maybe lots of math and just a little bit of science, technology, and engineering. So you don't have to have all of them in every problem for it to be a good problem. So that's a great question. Or I think it's pertanyaan, is that right? That's a good pertanyaan. All right, good question. So thank you.
Okay, thank you.
And Scott, we're almost out of time here. Would you like to make a final couple closing comments? I would like to start by challenging all the math teachers out there to try STEM. You know, you step out of your comfort zone a little bit, but try STEM. You know, that science is the natural world. The technology is modifying that natural world to make human needs and wants. Engineers create technology by applying math and science. And math is what ties STEM together. So those are my challenges to all of you math teachers to try to integrate a little bit of STEM in your own teaching. So Dr. Scott?
Yeah, thank you. I just have two more thoughts. I saw one of the questions that was posted was, how do you assess a STEM problem? That's very creative. There's lots of ways, but let me just give you an idea. You can assess whatever the students make. So if they're making back scratchers, you could say, well, does it work? Is this 80% and 20%? You can assess that. You know, you could try it out and say, okay, yeah, does that work? But you can also assess their process. So ask the students, what are the steps? What are the things you did to try and solve this STEM problem? And so that's one way you can assess it. And my final idea that I want to leave you with is this is something that we all can do. I know you can do it. It might seem very different or hard, but math is, as Dr. Reeves says, math is what ties it all together. And we have a great opportunity to reshape the future of math by bringing more STEM in. So thank you very much for your time. Is it Terima kasih?
Terima kasih, thank you.
Terima kasih. Sorry,
Terima
I'm not
kasih.
very good. I'll work on it.
Okay. Again, thank all of you. You know, I think our time is almost up here, so we'll turn it back over to our hosts. Again, thank you for letting us share. So, Hani, I'll turn it back over to you.
Thank you very much, Professor Edward Reeves, for chairing the session of Dr. Scott Bartholomew. And it was amazing presentation and discussion. Please a round applause to thank you. Well, ladies and gentlemen, without any further ado, I will invite the keynote speaker and moderator for keynote address 2. Professor Trena Wilkerson from National Council of Teachers Mathematics USA and chaired by Ms. Maria Suci Apriani from Sanata Dharma University, Indonesia. Maria Suci Apriani is a lecturer in mathematics education at Sanata Dharma University. She is currently as a vice head of undergraduate program in mathematics education. In 2014, she has pursued her Mathematics Master of Science at Gajah Mada University after finally finished her bachelor degree in Mathematics Education from Sanata Dharma University. Maria's research interests are HOTS, the development of the learning process, and educational statistics. Some papers have been published in international journals and have been presented at international conferences. Maria also contributes to the books writing about mathematics learning and statistics. Ms. Maria Suci Apriani, the time is yours.
Okay, thank you, Ms. Hani, for introducing me to the audience. My voice is here. Can you hear my voice? Okay, thank you, Ms. Hani.
You're welcome.
Yes, good morning, good afternoon, and also good evening, ladies and gentlemen. The Honorable Dr. Sumardiono as the Director of SEKIM, Dr. Farida Nurhasana as the Deputy Director for Program, and Dr. Susetio Widyasmoro as Deputy Director for Administration, and the prominent keynote speakers and moderator, and also the esteemed participants from Southeast Asia and beyond. Good morning, and once again, welcome to the international webinar series entitled Preparing for a Post-Pandemic, Reshaping the Future of Mathematics Education. Hopefully you are in a good condition and still excited in this webinar. Okay, it's my pleasure to become your moderator in this session. And before I introduce our keynote speaker, let me read briefly for the Q&A protocol first. Okay, please, the committee. Okay, for the Q&A protocols, each keynote speaker will present for 40 minutes, followed by 20 minutes for Q&A. And for Q&A session, there are two parts. There are for the participant who join in from Zoom. From the Zoom, the participant may leave their question on the Q&A box, and one selected participant will be given a chance to ask question directly. And for the participants who join in from YouTube, please leave your question on the link provided in the YouTube description. Okay, thank you. And now we are moving to the next session. Let me introduce our second keynote speaker. She is Professor Trina L. Wilkerson, and she is president of the National Council of Teachers of Mathematics, an international mathematics education organization with more than 30,000 members. She is also professor of mathematics education in the Department of Curriculum and Instruction in the School of Education at Baylor University. She teaches graduate and undergraduate mathematics education courses and conducts professional development and research. Trina previously taught high school mathematics. She has received multiple awards, including the 2021. She got Prakand Professional Cooperation Award from the International Technology and Engineering Educators Association. And in 2018, she got Outstanding Service Award from Association of Mathematics Teacher Education, Texas. And 2016, from Texas Council of Teacher of Mathematics, she got a Glenadine Gift Achievement Award. And 2013, Award for Excellence in Integrating Science and Mathematics from the School Science Mathematics Association. Okay, without further ado, let's welcome our next speaker, Prof. Trina. Can you hear my voice, Prof. Trina?
Yes, thank you so much. Thank you so much, Ms. Apriani. I appreciate it so much. And thank you for the opportunity to be here.
Okay, good evening.
Good evening from here, but good morning to you.
Yes, thank you. Okay, Prof. Trina, the screen is yours, please.
Thank you. I'm going to share my screen.
Okay.
And if all goes well, do you see my PowerPoint, Ms. Apriana? Is that right?
Yes, I see.
All right, perfect. All right, excellent. Well, thank you so much. I am looking forward to this, and I really enjoyed Dr. Bartholomew's talk on STEM, and he gave us some really good things to think about, and you're going to see some of them come up in our talk today. In our session today, we're going to talk about continuing the journey of learning mathematics, beginning now in 2021, but also beyond. And this idea of the pandemic is really something that we need to think about and what it has done to mathematics education. I'm honored and humbled by your dedication, your creativity, your resilience, and your care for your students. Each of you as teachers of mathematics, the families, caregivers, your colleagues, we've all been in this together, but have experienced it in different ways in the last 1 to 2 years. As president
of and on behalf of the National Council of Teachers of Mathematics, I thank you for all that you do in teaching mathematics. And I thank all the organizers for this opportunity to be a part of this event. And thank you, Mrs. Apriani, for hosting today and helping out with questions and those kinds of things. So I appreciate your moderating this session. So as we start today, we're going to look at this idea of reframing the idea of learning loss. We often talk about it as learning loss, but let's think about it instead of thinking about what students don't know. Let's look at what they have learned and what they have experienced and see how we might build on those opportunities. Okay, now we also know that all students did not experience the same thing and are still not experiencing the same learning opportunities, but they all have strengths and they all have some knowledge that we want to build on. So teachers, you have worked very, very hard during this time to reach students with lots of challenges. Families and caregivers have been engaged as well and been a part of this. So let's look at how we can offer learning opportunities now and moving forward to support their continued learning. So that's what we want to look at. We're going to look at challenges, opportunities, and then we're going to look at what we can do, what we must do as well. So as we're thinking through this, let's think about some questions to guide us. You know, how do we attend to perceived potential learning and opportunity gaps? Because I often think of this, instead of it being a learning loss, it's what are the opportunities that our students have not had? Then how can we foster the social and emotional well-being and cultivate a really safe learning environment for our students in whatever form that is right now? It may be in person for some, but more than likely it's still at a distance in various ways. How can we really best understand and value the different kinds of learning that each student has experienced over this past year? And what are the barriers and challenges? Those have been brought up in the Q&A today because there's so much in the curriculum. How do you address all of that? That's a challenge. And we also have students that haven't experienced the same thing. They haven't had the same access. But we also know that there have been some benefits. There's been some powerful learning by students. And how can we help build on that? What are the resources that we need to continue to support? And then I think a very valuable piece of this is what are those partnerships that we need to continue to build to move forward? So let's talk about these questions in relation to thinking about equitable mathematics teaching practices and structures that we may have. The mission of the National Council of Teachers of Mathematics is to advocate for high quality mathematics teaching and learning for each and every student. And in doing that, it is to support our teachers and partners in this effort. During the past year, countries, states, provinces, districts, schools, teachers, students, families, we've really grappled with mathematics teaching and learning during this pandemic. Some have thrived. Others have found the experiences very challenging, untenable, or even impossible to navigate. And all of it at no fault of their own, as the loss of hands-on and in-person group learning coupled with really inconsistent access to technology and instruction has been problematic. So we held an event this past year, earlier this year in April, called Understanding and Reframing this idea of learning loss in mathematics. Prior to that briefing, we did a survey of a lot of teachers and teacher leaders to get some ideas about what they were experiencing, what their goals were, and what they saw as the future and how to work with these. It really has shown that the learning challenges experienced during COVID-19 have really impacted the inequities. It's really shown up which students do not have access and which students do. And this panel that came together, they discussed this and they thought about what can we do to address the challenge. As a result of this, the National Council of Supervisors of Mathematics, the National Council of Teachers of Mathematics, and the Association of Supervisors of State Mathematics here in the United States put together a document based on a number of people putting input into this and helping to write it. But we published this particular document, and it's the one that I want us to look at today. I'm going to put it in the chat box. I think I'm going to put it in the chat box. I'm having trouble copying this, so give me just a minute. Oh, here we go. There we go. Now I can copy it. So if I can put it in the chat box, this is something that you can access and hopefully download for yourself, because we're going to reference this. So I put it in the chat box. And Ms. Apriani, can people download that, do you think? Can you
I
click on
think
it and be
yes.
sure?
It's already on the chat box.
Yes, I put it in the chat box. Have you
Yes.
clicked on it to be sure you can
Okay,
get
I
to
will
it?
try.
Thank you. Thank
Yes.
you. It's a lengthy document, so we're not going to read it word for word right now, but I want you to have access to it, and we're going to refer to some things in it because we wanted to put together a resource for our teachers and leaders here in the States to think about, well, how do you think about starting the school year and going back to school and continue learning in whatever format that might be. There are many who are still not able to meet face-to-face. Some are. Teachers are trying to figure out, well, what do we do? We have so much curriculum. Students experience things in different ways. So what are we going to do? And so what we did is we produced this document that's filled with resources that I hope might help you as well in thinking about our continuing this journey in mathematics. Also wanted to share that in the title of this webinar that you're doing, it's really thinking about how we can think about the future. So I would challenge us to rethink and reimagine what mathematics education can be. So let's think of it that way. Let's use this as an opportunity to really think about the future of mathematics education. Okay. And so I'm going to highlight some of the things in this document that I think might be useful for us to talk about. So the why about this. So all around the world, we continue to experience many challenges with the pandemic. This includes in education, in our schools, our students, our teachers, families, caregivers, communities, businesses. We must really build and capitalize on our students' strengths and opportunities in mathematics now. We need to acknowledge the difficulties and the disruptions because they've been many and varied, and different students and teachers and others have been impacted in different ways. In the opening of the document, you will note that that we acknowledge these disruptions, that we know that there are problems that we have, and they raise questions like, how do we attend to all of these perceived learning difficulties and opportunity gaps? How do we foster this social and emotional part of this and help our students? They have really dealt with a lot emotionally. How can we best understand and value what we know about learning and teaching with our students? We have the opportunity to really rethink mathematics. Okay, so let's do that. In this document, there are 3 aspects to it, you'll see. One is we highly advocate for starting with grade level content or content level, whatever grade or course that you're teaching, that you start with that, okay? That's very important. Now, here in the United States, we have had many who've wanted to go back and remediate and fill in a lot of gaps. Well, we don't know what all the gaps are. Students have experienced different things. So instead, we need to start where the students should be. But in doing so, we're going to talk about how do you do that when you know some of the students have not really had the opportunity to learn certain things. So we're going to talk about that. The second one is we really need to focus on equitable, effective teaching practices. Dr. Bartholomew mentioned that around STEM, about engaging students and hands-on activities. And I noticed in the opening of watching the video, you all do some very powerful hands-on engaging things with your students, but developing deep mathematical understanding. So we're going to look at that. How can we build on those effective practices? And then the third one, we might not get to do as much on, but the third one is advocacy. How do we advocate for all of our students so that they have access to really meaningful mathematics? All right. So let's first look at focus on grade level content. So where to begin? There's so much. Students have missed things. Where do we even start? We need to support each and every student. It's essential in developing a deep mathematical understanding so that they can understand and critique their world through mathematics. And my favorite part is so that they can really experience the wonder, joy, and beauty of mathematics. And I saw that in your opening as well. You want students to experience the joy of mathematics. And that joy comes often from understanding the mathematics and seeing it in their world, being able to understand their world. And all of this contributes to our students having a positive mathematics identity. So again, we advocate for starting with grade level or course level content. So how does the content that you're to be teaching support students in their development of their identity, in their deepening their understanding? And how do we attend to these learning gaps that some of them have had, or opportunity gaps? So how can we do that? And the key that we have been sharing is that It is that we need to make sure that our curriculum, what we're teaching, is coherent and we make connections. We may not be able to teach every single detail that we've taught in the past because students are trying to fill in places that they have not had the opportunity to learn. So one of the things is to identify in your curriculum, whatever your grade level is, whatever your course is, what are the big main ideas? What are the essential understandings? And can you map those out in a way so that you can show how they're connected? And then think about how you can approach teaching with your students and help them to make those connections. So you may not be able to teach every single detail, but instead look at your big ideas. What are the essentials that students need? And then remember that this is long-term. We're not going to be able to overcome everything in 1 year. It's not going to be possible, particularly for our elementary and middle school students, even some of our high school. We've got to take some time to build in for them to get all the learning opportunities that they missed. The second thing that we bring out in this is a shift between what we call remediating students. And instead of thinking about remediating students, assuming what they don't know and say, we're going to fill all that in, but instead support them in learning the grade level content or the course level content that they're to be learning. And then we're going to scaffold that. In other words, we're going to build in things that help them to understand it. So we're going to talk about what that might mean. So again, if instead we begin with that grade level, course level content and give students multiple opportunities and choices in showing their understanding and providing those just-in-time supports for targeted concepts that are the big ideas, then we can focus on really supporting our students and working with them, and then we can apply those effective teaching practices. Now, in words, it might sound a bit easy, but it is definitely not easy. This is going to be hard work for us and for our students and for our teachers. This is a quote that's in Continuing the Journey. It's particularly for this coming school year, which in our case, we have just started a new school year. And in it, we must begin with building coherence through the content and shifting from this idea of remediating everyone to instead supporting them in learning the mathematics that they need to be learning at that time. But we might need to fill in some things that they have missed. And different students will have missed different things. They will have experienced things in different ways. So you'll notice that in this is one of the tables. I think that's one of the powerful things in this document is it talks about, here's some ideas in table 1 that talk about ways for adhering to that grade level content. And it gives us some questions that we can think about. And it's like, how do you find ways for us as teachers? You know, we want to enjoy our work. We want to collaborate. We want to work together and plan together. But what we want to do is focus on teaching to students' strengths. How do we know that? How do we learn who our students are? And I will tell you that the past year or two has been very challenging to get to know our students because we're not face-to-face. Dr. Bartholomew talked about that. We're not face-to-face, so it's much harder to build those relationships. But that's one of the things that we need to do. Find ways to get to know our students and what they've experienced over the past year or two. And then the third one that I wanted to mention was we need to connect to the major work of what the learning needs to be. So what are the big ideas? What are the major areas that need to be covered and how are they connected? All right. And so these are some things to think about. You'll also notice that there are a lot of links that you can go to get resources to help you in thinking about this. So I challenge you to think about using this document, the questions that are here, to have conversations with your colleagues. So of course it's a math conference or math session here. So we would love to do some mathematics. So this is one of my favorite problems. It's counting cubes task. And you can certainly, if we had cubes, we would certainly get them out. We would build these and we would look at patterns. But here's what I want you to do. I want you to share in the chat box, and I'm going to bring it up for myself so I can follow it in just a moment. This is a task. And the first thing I want you to do is whatever grade level you teach in mathematics, whatever content area you teach, just want you to think about that for just a moment, because this is a problem that can be used in elementary, middle school, and even high school. And what I would like for you to do in the chat box is I would like to know, what do you notice? When you look at this, what do you notice? So just type in the chat box things you notice about this picture. You see patterns. Thank you, Mohammed. What do you notice? So we see some pattern. And we could talk about those kinds of patterns. Some number sequences, interesting. We might look at how those number sequences are connected to the patterns we might see. If we were together in the same room, we would look at, I would have you explain the different patterns that you see. Oh, a tower, there you go. All right, because the patterns that you see, the number sequences that you see might not be the same as someone else in the class. There are many different ways to think about the patterns here. So we've got patterns, number sequence, a tower. What about those of you who are teaching functions, for example? Do you see anything that you can do with that? Do you notice anything about that? What kind of pattern is it? All right, now, so while you're still thinking about your noticing, one of the protocols that for thinking, and it allows every student to be able to engage in the problem, the first part of it is, what do you notice? You can ask students what they notice, and they might just notice there's some blocks, there's some cubes, there's patterns, it's growing, it's a tower, it's number sequences, lots of different things. But here's the next thing. The second part of this is I want to know, what do you wonder? What's your question? You're looking at this picture. What might a question be that you could ask? What could a question be that you might ask? What do you wonder? Or what do you think your students would wonder? Oh, is there any cube in the center at the bottom? That's a great question. And if we had the cubes to show the building, we would start with that first one. And then the question is if that first one is underneath, is it? Okay, and then is that part of the pattern? That would be something you would need to establish, okay, because that affects what happens with the pattern. So great question, Nindu. Great question. What's another question? Or what do you wonder when you look at this? What do you wonder? Oh, here we go. How many cubes do we need to build in a tower? So we might, for those of you who are teaching younger grades, just counting, they might just do the counting. Others might ask, say, well, what would the next one? This is the first, second, and third. What might the fourth one be like? Okay. How many cubes would there be in the fourth one or the fifth one? The number of cubes, there you go. Nurse says they're 1, 6, and 11. And we might ask her to explain, well, how do you get that? How many cubes will be needed to do the next figure? Excellent. For those of us who are pushing, can I add a cube randomly? If I want to keep this pattern, where does the next cube have to go? If I want to create a different pattern, what might it be? What's the fourth figure look like? I might even get adventurous and say, okay, maybe we've figured out 1, 2, and 3, and maybe even 4 and 5. And I may go, okay, what if I wanted to know the 100th figure? Wow. How many cubes would it take to do that? And how could I figure that out? Well, it turns out in this particular problem, that does turn out to be a function, and you can do this tremendous amount of mathematics in it as well. The website that you will have access to there, I think you will be able to access it a little bit later. This is actually a case study. So for those of you who do professional development, you might want to take a look at it, and there's some student work there and that kind of thing. So when you consider this across grade levels, there are a lot of different math connections. There are multiple representations going on. There are patterns and counting. There are recursive and explicit thinking. There are different equations you could come up, generalizations. You could make conjectures. You could use a table or a chart, drawings, graphing, symbolic, making connections. You could find a real life application of this. Think of it as an engineering problem. You could look at the manipulatives that you might be able to use. Could you do this with technology, like a dynamic graphing tool or a drawing tool? Can it be done in small groups? And what would that mean for collaborative inquiry? So one of the beauties of this problem is all students can enter this problem. What they might do with it might change depending on the mathematics that they've had. You could use a task like this to find out where your students are in relation to your curriculum, if this has to do with your curriculum. If yours is about counting, you might deal with it that way. If yours is about patterns or about functions, you could find out what your students already know about this. I love that. That's a great one about how does the pattern actually grow. So this is a kind of task that you can think about of how you can engage students, no matter the mathematics that they've had, the experiences that they've had, and then figure out how you can build on that. So it has to do with the shift of scaffolding and supporting away from remediation. Now, scaffolding may not be a word that you use. I don't know. It's one that we use here quite a bit, but it's still unclear what it means. So I thought I'd share a definition from the Mathematics Education Journal in Science and Technology. It says that scaffolding is an act of teaching that supports the immediate construction of knowledge by the learner. It's much like you think about scaffolds for like if you're building something, you will build a scaffold so that you can make the construction. Well, it's the same thing in teaching. It's the act of teaching that supports the immediate construction of knowledge by a learner. So the teacher is finding a way to help the learner build their knowledge. Second part of that definition, it provides the basis for the future independent learning of the individual. So this scaffolding that we provide, this support that we provide to our students, helps them to build their own learning and understanding. And so remediation, though, is assuming something that students don't know and practicing that, which may or may not be the thing that they don't understand. So we have to really think about that. But again, start with this idea of supporting our students. So a call to action, what are some productive ideas that we can think about with this? Is keep the joy and humanity in teaching and learning. This is table 4 in that document. Focus on and teach to students' strengths. Work collaboratively with our colleagues to plan that mathematics, to look at the big ideas, the concepts. Connect to the major work of the course or grade level that you're teaching. Scaffold, like I talked about. Number 6 is eliminate tracking, and I'm going to come back to that one. The seventh one is really keeping in touch with families and caregivers so that they understand as well what we're trying to do and have them be partners in this work. Number 6 is eliminate tracking. Now, I don't know in your curriculum and in your schools whether you have an issue with tracking, but in the United States, we do. And tracking often is done early on in students in early grades, and they're identified early on to say, oh, you're not very good at this. We're going to put you in the low-level group, and then we're going to put this student in the high-level group. And what happens is when that's done is it often keeps students from access to really engaging mathematics, and it has them stay in those low levels and are not able to move forward in the mathematics, and it really inhibits their opportunities for learning. So what we're advocating for here in the United States is not to track our students, but instead engage them all in really rigorous mathematics, but provide the supports that they need. Now, again, this may not be a problem in your country, in your school, in your district, but it is here in the United States. So we want to make sure that our students all have access to really rich mathematics. So the second part of that document, remember I told you there were 3 parts. The first part we just did that had to do with starting with on grade level content. The second one is really having a foundation of equitable, effective teaching practices. And the first one has to do with really cultivating a productive instructional mindset and practice. It is really imperative that we really believe our students can do the mathematics, all right? And that is an equitable way to approach our students. And particularly for students who have been marginalized, especially during COVID, that have not had access. And we want all of our students to have access to that mathematics. The second one is to help build positive mathematical identities. And we do this through really engaging our students in the mathematics and in positive ways where they can grow and they can learn, and that they know that it's okay sometimes to struggle or they may not understand something, but then they'll work and persevere and persist to understand those things, and they're successful. Earlier when Dr. Bartholomew was talking, he was talking about the engaging STEM activities. That is one way of really building positive mathematical identity, because the students are really engaged in solving a problem that maybe matters to them. The third one is creating an equitable classroom culture where all students feel like they belong in the classroom and that they're engaged in the mathematics. The fourth one I've already mentioned is we need to help our students to make connections. Dr. Bartholomew talked about this as well, that one of the key important areas was making connections. And often we have to help our students to do that. And I think when we help them make connections both to real life and between mathematical concepts, that then they have a better understanding of the mathematics. The fifth area has us, when we're thinking about this, has us thinking about creating a culture of collaboration. Now, funny about this, I'm not talking about a culture of collaboration for students. We do want that as well. We want them to collaborate, to work together to solve problems. But we also want our teachers to have the opportunity to work together. There are hundreds of teachers with us here today. I hope that you will find your group to work with in order to plan and to think about the challenges we have ahead and to think about how we might reimagine and reshape the future of mathematics education. Your voice matters. Every single teacher voice matters. So when we're thinking about this as well, there are sometimes unproductive mindsets that we have that we may need to disrupt. We might need to think about and disrupt a linear view of learning that creates barriers between content by suggesting a particular skill or concept has to be mastered before they move to another one. It may be that students can work on one while they're learning another, and then that other one grows. We need to avoid deficit language. Think of our students in a positive way and use positive language with them instead of saying those are our low kids, or those are our slower kids, or those are our kids that can't do this. But instead, think of them in a positive asset base, their strengths, instead of a negative deficit view. And these may be, you can look at all the rest of them to see, but there are a number of areas that we need to think about as we're reimagining the future of how can we make this a positive experience and think about the strengths of our students. Earlier, I talked about the support and scaffolding. Another way to think about that scaffolding and content connections is looking at the various representations, like the pattern problem that I had earlier. You can connect the symbolic to the graphic, to the manipulative, to the symbolic. So there's a number of different ways. But planning authentic classroom activities that allow students to explore mathematical concepts once they're introduced, extend that knowledge, connect it to other concepts. Those are the kinds of things that we need to think about as we're thinking about the future of the mathematics that we want to teach. This connections approach is essential. And together with the use of multiple representations, developing an understanding of mathematical structure, all of these will help our students to engage in the mathematics and make connections to mathematics that they may have missed over the past year. This is a quote that I will give you a chance to read, but we should recognize and believe in and build on the strengths of our students. One role of us as math teachers and leaders is to really ensure the continual affirmation of our students' positive math identities through their learning experiences, giving them feedback, building on their strengths, and providing activities and structures to help them to really become resilient, strong problem solvers. So how do we do that? We need to work together in those practices. So we need to have our students be invited into the mathematics, make those connections explicit, ensure grade level instructional experiences, keep that rigor and high expectation for our students, connect the math content, and really cultivate instructional mindsets and practices that are positive. All right. So the third area has to do with advocacy. And in this particular one, as we continue our journey this year in 2021, 2022, and as we move forward into the future, we need to think about how do we work together across mathematics education. And now is the time to really examine our current policies and practices and systems that are in place. Are they serving our students? Are they serving our teachers? And how can we help our students, particularly those that have been marginalized? And I don't know which one of your students have had the most challenges, but here in the United States, we've had students that have not had access to technology. We may have had great visions of doing things virtually, like Dr. Bartholomew talked about earlier. That's wonderful for those that had access to the technology. But what about the areas that did not? How do we deal with that? And we need to work with and advocate for mathematics for all of our students. So all of our voices are important, both individually and collectively. And we need to build partnerships to do this work. And who are your partners? Who do you want to work with? Who can you advocate with? Who can you help to empower in this work? Think about the communication. Who needs to hear the messages? What are the messages you want to get out? How do we communicate those? What are the resources we need? What kind of networks? And you have a beautiful network here with Siamo. This is wonderful. You have a powerful partnership across multiple nations to work together in this work. So as we think about that, in the document, you will see some advocacy practices. Some of those may apply in your situation. I would encourage you to look at those and to think about which ones will help you in the work that you are doing. What are the challenges and barriers? And how can you address those together? What are the alliances or partnerships you need to build? What kind of conversations do you need to have with your communities? I noticed one of the in the opening about one of the beautiful STEM communities that you've been building, and that was unveiled the year before COVID hit. That's wonderful. That's a powerful, powerful partnership. How can you continue to build on that and expand it to other communities? All right. Your voice, your talents, they matter. So again, there are 3 areas, beginning with grade level content, and then how to make those connections, using effective math teaching practices, and really advocating to help our students and our teachers in their work. So in Catalyzing Change, this is a document that I shared in a previous webinar that I did, and some of you may have been at that one, this as well. It talks about that we need to broaden the purposes of learning mathematics, create equitable structures for our students, implement those effective teaching practices to help our students to develop those deep mathematical understandings. There are also some other documents, and again, you will have access to this PowerPoint. These links will take you to even more resources, some of which may be useful to you in your work. We have a virtual conference coming up at NCTM. So hopefully some of you might be able to engage in that. We've had people all over the world engage in the virtual events, just like it's happening today. We've had a number from the Philippines, just from, I hate to even call out a country, Singapore, multiple countries. So we invite you to consider that. It's a wonderful way to continue to build partnerships. So as I'm closing, I know we have a little extra time, so I'll have some questions. This process of continuing this journey of rethinking and reimagining is very complex work, but it is also long-term investment that we need to do. It's not something we're going to fix in a very short period of time. It's something that we have to do together. We can learn from each other. So I would encourage you, for those of you who are part of the webinar today or view this later, to think about your role. Who can you work with? Who do you want to collaborate with? How can you have your voice heard in thinking about the challenges and the barriers that you're facing, and how you can help your students in their journey to learn powerful mathematics? So I thank you, and I appreciate being here today, and I look forward to our question time now. So I'm going to stop sharing, Ms. Apriana, and that way you can have it back. How about that?
Okay, thank you, Prof. Trina, for your interesting presentation. Okay, let me to share my screen. There is one question from the Q&A chat box on the Zoom. Okay. Okay, wait. Yes. Okay, do you see my slide, Prof. Trina?
I don't see a slide yet.
Okay.
It hasn't come through.
Okay. Can you see?
Yes, I can now. Yes, I can.
Yes. Okay, thank you. This is first question from the participant. Is there any tips and tricks how to encourage students to make they have ability in mathematics to students that they underestimate their self in mathematics? Please, you can answer.
Thank you. This is an excellent question. And it is one, it's interesting that you asked this question, because this is something that happens to our students here as well. We have students that don't have confidence. They don't feel like they can do the mathematics. They don't feel like they understand it. And when that happens is they develop a very negative self-image about themselves in mathematics. So how do you overcome that? One of the ways that, just to share an experience, I taught high school for many, many years. And I had a group of students in one class that really had never been successful in mathematics. They were in a geometry class. And in that geometry class, I discovered that they had never been successful in mathematics. And that was their problem. They did not feel like they could do the mathematics. So what I started doing is I started engaging them in problems that were of interest to them. That was one thing, but also where they could experience success, that they began to experience success. And when they found out they could be successful, so I provided questions or different kinds of support to help them in this. I didn't give them answers, okay, because I don't think that's the way to do it. But instead, I helped them to think about the problem, or I helped them to understand what kind of questions they should be asking or tools they could be using. And when they started experiencing success in their own understanding, then later they were willing to take on the more challenging problems. Because the idea was, I don't know if this happens to your students, but often I would give out a problem to do. You know, I'd give them a problem, and immediately students would raise their hand and say, I don't understand. I don't even know where to start. And my question would be, you haven't even had time to read the problem yet. And it's because they already were so not confident in their mathematics that they didn't even want to try. They didn't even know where to start. So a couple of things. One is I had them experience success in the mathematics. When they became successful, then they were willing to try some of the more challenging problems. The second one is that I help them to understand, one of the other things is to help them to understand that making mistakes or not knowing an answer quickly is not a bad thing. And instead, we can learn from our mistakes. What have we learned from that? Why do I know that's not an answer to this problem? What could be the reason why something else might be the answer to the problem? A third way is having students really talk about their understanding in the mathematics and creating an environment in your classroom where it's safe to do so. Again, I don't know about your classrooms, but I know some of our classroom students are afraid to say anything because they're afraid to be wrong. They're afraid they'll be embarrassed. They're afraid that someone will make fun of them, or the teacher won't be proud of them. Okay. But instead, creating an environment where it's okay not to know all the answers. Okay. But what's not okay is not to ask questions and not to try. We want them to persist. It's not a trick, but it is a methodology. One of the other practices is having students work collaboratively, working with a partner. Sometimes they will talk to one another before they will talk to the teacher. They'll ask each other questions. And I don't know if you've experienced this, but sometimes I'll have a student who'll be able to explain it to another student in a way they can understand it better than I could. Okay. I also think another way is having students voice and revoice. So like when a student explains something, then having another student, okay, so what did you hear this other student say? What made sense to you? Do you have a question for that student? And then just building that collaborative culture so that students feel safe to do the mathematics and to help build that positive identity. That was probably more than you wanted to know, but those are some ideas. Yes, put in the chat box for you. You all put in the chat box, what are some ways that you try to build that positive math identity for your students? What do you do? So in the chat box, share with us, what are some things that you do to help build that positive math identity?
Okay. Miss, wait.
Have anybody who's going to share?
Miss Dian? Miss Dian? Okay. Okay, Prof. Trena, I think it's a good answer from you, but I think Miss Dian, I don't know where is she? Okay, I observe the pattern of Fibonacci at the garden.
So Nunu, that is actually an excellent point. Is when you're giving a task, for example, okay, when you're given a problem or students seeing mathematics in their world, is them being able to share the mathematics that they see and that they understand, and then build on that. And I love Fibonacci is one of my favorites, by the way. And one of the things that I like to do to help my students is to notice mathematics in their world. I call them math encounters. And so I encourage students to bring in their math encounters. All right. And I noticed earlier today when Dr. Bartholomew was talking about, he talked about notice what are some problems that could be solved. And he was talking about engineering and STEM type problems, but you can do the same thing with just any mathematics. Where do they see mathematics in their world? And you have some beautiful, beautiful, you can think about art, patterns. The Fibonacci sequence shows up in so many wonderful things. Sierpinski's triangle, we could go on and on.
Yes. Okay. Thank you, Prof. Trena. Okay. Can I? Okay. Per Bernal, associate experiences from real life situation as much as possible, so that they can relate and feel that they are using that. Like, hey, you know this,
Yes.
something like that.
Yes, and Pearl, that is right on target. Finding things that the students can connect with, I think is very, very powerful. So earlier when I talked about connections, I talked about it a lot in relation to connection to the mathematical ideas, but they need the connections to their real life, their everyday life. One of the powers of mathematics and purposes of mathematics is for students to understand and critique their world. So I think that's very powerful. So thank you for sharing that. That is definitely a way. And that way the math makes sense, that that's why they need to learn it. So Ms. Apriani, if there are not any more questions, I have a question, but we'll wait and see if there are any other questions from them.
I think there is one question from the chat box. I will share screen first. Okay. And for the second question, how to change the students' paradigm about math, that math is so easy subject. Okay. Can you read my?
So are you asking how to change the paradigm so that students don't think it's hard? I get, can you clarify that for Ms. Apriani?
Okay, maybe this is from Mr. Nur Hadi. Can you explain directly to Prof. Trena?
Yeah, are you talking about students thinking mathematics is too hard? And how do we shift that paradigm so that they can see that they can do the mathematics?
Okay, Mr. Nur Hadi. Okay. Okay,
yes,
Mr. Nur Hadi, can you
yes,
explain more about your questions?
Yes, I want your suggestion, Prof. How to change the student paradigm about mathematics? Yeah. So student paradigm today that mathematics is so difficult. How to change this paradigm to be that mathematics is a subject? I think so.
So yes, sometimes you are right. Sometimes our students think that mathematics is so difficult that they cannot do it, right? They just think they cannot do it. It is too hard, it's too difficult, and I can't do that. But I think it goes back to what was talked about earlier, is that having students experience success in mathematics is really important. Helping students to see connections in mathematics and that they can do the mathematics, and that mathematics is something that they see, as was brought out earlier by Pearl, is that it is something they see in their everyday life. It is something they encounter every day in their life. Now, I realize that when you get to certain things, maybe in high school, secondary mathematics, that every student might not see, I don't know, the quadratic formula or something, or the quadratic equation, or some trigonometric function. They might not see it, but I think that's something that we as teachers can help bring in, is what are the mathematical connections that are out there in their world to help them make sense of the world. I think about, I'll tell you another one I think is so powerful, is statistics education right now, and understanding data, how important that is now. Students are encounter all kinds of data and graphs. Do they understand those? Are they able to interpret them? Do they make sense out of them? And I think that's another way that we can help students see that mathematics does make sense. It is not something that is a secret. It's not a magic box. It actually makes sense and it connects. And I think that that's one of the other things about keeping mathematics from being so difficult. I think it's all right for mathematics to be challenging. I like challenging problems sometimes. I like to have a problem that sometimes I can't solve the first time I look at it. And then I go back and I work on it some more and I do it from a different perspective and I persist at it and I'm able to figure it out. But if I don't have the skill set and the belief that I can do it, then I will stop trying, right? I won't even try. So instead, we need to help students to be successful, to help them make connections, to see it in their lives and why it's so important, and then have them make those connections so that they will want to continue to learn, continue to persist, and continue to persevere. And that mathematics is not just something they have to memorize and that doesn't make sense, because it does make sense. That's what the wonder, joy, and beauty of mathematics is, I think, is because it does make sense. Let's see. There you go. What we can do is ensure that the students, that's exactly right. They need mathematics so they can learn. And it is true, when students have a positive experience with the mathematics, then they experience that joy, and then they're willing to continue on. I love that. Sometimes things are very hard to connect, you're right, with real life, like inequalities and trigonometric functions and things like that. So I think that that's a challenge, but it's one that we can do. When I think about roller coasters and pendulums and all of those things are things that are in real life. They're connected to STEM, for example. So there's some beautiful ways that we can think about using the mathematics that way. Okay. Yeah, there are a lot of students who just don't care about the mathematics. And I know for me as a teacher, it was for me to get my students to experience that joy of mathematics, that understanding, and seeing how it applied in their real life. Okay. I think that those are important key things, but not easy.
Yes, it's not easy.
I also think that's why we need to collaborate, that we need to work together. There's so many resources out there now. NCTM has some, but there are lots of other resources, many of them free resources, where we can get those ideas about how to apply the mathematics in real life. Because I don't know all of the applications, but I know they exist. All right. And sometimes I have to search for them. So just think about, if we collaborate and work together and identify those, then we will be much more powerful with our students.
Okay. Okay. Thank you, Prof. Trena, for your answer. And this is for a question for the participant who joining from YouTube. Okay.
Okay.
And how to create scaffolding in our class, which is many level of thinking. Can we do classical or any idea? Okay.
Okay. The first part of that question about the scaffolding, where, if I understand it right, you're talking about their students in your class will be in different levels. They will have different kinds of thinking. They'll have different kinds of understanding. They're not all in the same place. And particularly with the pandemic, they've not all had the same kinds of things. One of the things that I find that works with some of our students is when we work and have them work in small groups, and we work on targeted kinds of things, math concepts that we're working on. I might have them in small groups where they're working on particular math concepts that I know that they need to work on in a particular way. A second way of doing the scaffolding, where you have different kinds of understanding in the classroom, is thinking about the questions you need to ask, having resources and technology available for your students when you can. All right. So I think those are other important ways that we can do that. Having tasks that you may have, just to give you an example, you may have a particular math goal. There's a concept that you're studying, but maybe there are 2 or 3 different types of tasks that you might do that you will have students pick to engage in. Like, all students might not do the same task. They may do different tasks to accomplish the same mathematical goal. Okay, but because they have different experiences and need different things, then we might have them do different kinds of tasks. So we call it differentiating. I don't know if that's a familiar term, but we differentiate the instruction a little bit. And so small group work is very important. Having them work on collaborative tasks, having them engage in problems that can be entered in multiple ways is really important as well. So those are some of the ways. And then questioning, having types of questions. And we even have cards where I have questions written out where the students are reminded to ask each other questions as well. So they don't always have to be asking the teacher. They can ask each other the questions.
Yes. Okay, thank you, Prof. Trena. I see there's one participant who raised hand. He is Deng Mas Negara. Okay. Mr. Deng Mas Negara, can you hear my voice? And you can directly post your question to Prof. Trena, please. Mr. Deng Masnegara. Can you hear my voice? Okay. You can directly ask question to Prof. Trena, please. Okay. There's no response from Mr. Deng Masnegara. Prof. Trena. Okay. Prof. Trena, thank you for your inspiring presentation. And I get two important things to create to make the quality of our teaching of our learning process in mathematics to be more good. Okay, there are diligence and also ongoing commitment. I think there are two important things that the teacher must have so that the quality of the teaching and also the learning process can be better, especially in the post-pandemic. Okay, once again, thank you, Prof. Trena, for your inspiring presentation, and hope you have sleep well because it's still night in your place. Okay, thank you so much, Prof. Trena. Maybe you want to give a closing statement or something, please.
Well, first off, thank you, Ms. Apriani, for moderating. I thank you so much for that. And Hani, thank you so much for hosting today. And Dr. Smardano, thank you so much for the invitation and for being a part of this. But I also want to thank all of the teachers who are here. Thank you so much for the work that you do. Thank you so much for your commitment. And I just appreciate so much your hard work and your dedication to teaching mathematics. I love teaching mathematics, but I know it's not an easy thing, particularly during this pandemic. We have some challenges ahead, but I think together, in fact, I know together we can move forward. So thank you very much.
Thank you very much.
We have brilliant students. Just remember that. Our students are brilliant. We just have to figure out what that brilliance is and how to build on that.
Okay, thank you, Prof. Trena. And ladies and gentlemen, please give big round of applause for Prof. Trena. Thank you, Prof. Trena, once again. And the screen, I give back to Ms. Hani. Thank you.
Well, thank you very much, Ms. Maria Suci Apriani, and also our keynote speaker, Professor Trena Wilkerson, for having such a wonderful session. And participants, please give a round of applause for our keynote speakers and moderators. Ladies and gentlemen, before we start the last keynote address, I would like to say thank you for all of you who joined the giveaway through Sikkim official Instagram, and the giveaway will end soon. So please join us, and the committee has shared the attendance links on Zoom chat box and YouTube description. Please ensure you fill the attendance list as the record of your participations. In the last session, we will have Associate Professor Jakut Singh Dindyal from the National Institute of Education Singapore, and will be chaired by Mr. Subhan Aziz Awaluddin from Muhammadiyah University of Professor Dr. Hamka or UHAMKA. Subhan Aziz Awaluddin, usually called Subhan, is currently a lecturer of Mathematics Education Department, University of Muhammadiyah Professor Dr. Hamka or UHAMKA. He holds a bachelor degree in mathematics education from UHAMKA in 2013. He pursued his master's degree in applied mathematics at Prince of Songkhla University, Thailand, with South ASEAN Scholarship for International Students. He's been teaching at UHAMKA since 2017 and focuses on mathematical finance, particularly in volatility modeling. In addition, he also contributes in the development of mathematics teaching through Indonesian Mathematics Educators Society, or IMES. He can be contacted through his mobile phone and his email address. Mr. Subhan, the time is yours.
Yes, thank you very much, Ms. Hani Palupi. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone, ladies and gentlemen, all distinguished professors and teachers. Selamat pagi, sawadikap. So good morning, everyone. Thank you for being here in virtual seminar this morning. My name is Subhan Aziz Alil from Mathematics Education Department, University of Muhammadiyah, Professor Dr. Hamka, Jakarta, Indonesia. Today, we are pleased to have Associate Professor Jagut Singh Dindia from National Institute of Education of Singapore. And now, let me read a brief introduction of him. Jagut Singh Dindia, or his nickname is Daya, Associate Professor Daya, is an Associate Professor at Mathematics and Mathematics Education Academic Group, MME, of the National Institute of Education, Nanyang Technological University in Singapore. Daya has prior experience as a secondary school teacher and was a former lecturer at the Mauritius Institute of Education. He has been teaching a wide range of mathematics education courses at NIE and has also regularly supervises research students. His current research interests include teacher education, including teacher notation, reasoning, and proof in mathematics. Wow. The teaching and learning of algebra and geometry, problem solving, and the use of the task in teaching of mathematics. Some recent research projects that he has worked on include teaching noticing, teacher education, and problem solving. Daya is a member of several international professional organizations, such as Mathematics Education Research Group of Australasia, America, and National Council of Teachers of Mathematics, and CTM, and the International Group of the Psychology of Mathematics Education, PME. And today, he will be sharing with us his expert opinion based on his research and how the preparing for our post-pandemic, reshaping mathematics education learning. With that, I ask that we give your full attention to Associate Professor Jagut Singh Dindia and help me in welcoming him. Associate Professor Daya, please, the screen is yours.
Okay, let me share my slides. Okay. Can you see my slides?
I haven't seen your slide, Professor.
Oh.
Yeah.
Sorry for that.
We can see your.
Can you see my slide now?
Screen of the laptop, but we don't see the slides.
I'll try again.
You can open your slides and then.
I'm sorry for the hiccup.
Yeah.
Can you see it now?
Haven't yet, sir.
Oh my God.
Maybe you can click the file of your slides.
No, I'll try it again. Okay, give me a minute.
Yeah.
Can you see it now?
Yes, I can see, sir.
Oh, sorry for that.
Please.
Okay. All right. Okay, thank you, Mr. Suban. I'm sorry for the hiccup. And thank you to Sikkim for inviting me for this lecture. I have had some great people who preceded me, all right, and I'll try to live up to the expectations. My sharing will have not too many examples, but I will have more ideas about things to do and probably not to do as well. And a bit bordering on the historical aspects as well. And I borrowed some ideas generally from just education at large. And in particular, I want to use a lens from NCTM. We have Dr. Wilkinson here, from the principles and standards of school mathematics, to look at the curriculum. And in particular, I'm going to look at the principles, not so much at the content standards. Basically, this is probably what we would like education to be. All right. Learners are engaged, teachers facilitate learning, learning resources are adequate and diverse, schools are safe and inclusive, systems are well managed. This is what we want to have. But we know that we had this pandemic. I'll flip through some of the slides a bit quickly. And many educational systems were unprepared. Some schools were partially closed, and some form of remote learning started where possible. In particular, countries like Singapore had a previous experience with SARS, for example. There was some preparation already in place. But I understand that there are lots of countries which were taken unaware. So the long-term impact, we yet don't know because things are still changing and it's still quite uncertain. I like this quote from Schleiter: real change often takes place in deep crisis. This moment holds a possibility that we won't return to the status quo when things return to normal. So what we have right now is, rightly so, this is put up by the World Bank, global learning, a crisis within a crisis. And maths education cannot ignore this. Crises are not new to mathematics and maths education. They have happened in various ways. I'm not going to dwell too much on this, just quickly. You have the slides, you can follow the slides. But there have been several crises in mathematics. Okay, but they have been more philosophical, and school mathematics has quite often remained aloof of these debates. But the questions are, how has the pandemic affected the teaching and learning of mathematics? What changes has the pandemic brought about and that are likely to remain? What are the long-term implications of these changes? How should we be prepared for the future? How future ready are we? These questions pertain to one or more aspects of the curriculum. Of course, there have been minor crises in mathematics education as well, all right? Like the reforms of the 1960s, the back to basics movement, the problem solving movement, all right? Or even the standards movement, all right? So there have been crises in mathematics education as well, but I will call them minor. Probably the biggest of the lot was the reform of the 1960s. In these kind of issues that we had, or crises that we had, we were fairly clear about what our intended curriculum was, the implemented curriculum was, or the attained curriculum was. It did not always translate into meeting the objectives. There was a lot of optimism, but also a lot of criticism. Maths education benefited from borrowed theories. Countries benchmarked their own practices against their own mathematics education practices against Western countries in particular. And after the international comparative studies, like TIMSS, PISA, TEDS, and so on, against leading South Asian countries as well. So we have heard, for example, of Singapore maths, all right, being quite popular in certain parts of the world. Resources for teaching mathematics to huge leaps with the advent of technology. Research in maths also started to influence more and more the teaching and learning of mathematics. And with globalization, there was more sharing of ideas between different countries and regions. And if you look at issues, unlike the reform of the 1960s, which was more about military dominance between the West and maybe the Soviet bloc, nowadays what has happened is that it's more in terms of knowledge is power, all right? Knowledge is something that we value. So here it's more like who is going to have a better school mathematics, who is going to do better in mathematics. And there is a different kind of ideology right now. So our assumptions during the crisis periods of what has happened previously has been that schools will be open, teachers will be there, classroom will be there, and face-to-face teaching will be done all the time. There was no threat to the lives or potential threat to the lives of personal well-being of teachers and students and other stakeholders in the system. So what are the implications for the teaching and learning of mathematics? How will mathematics be taught in schools and how will students learn mathematics? And the way forward. Scanning through the literature, all right, I find one thing. There is a lot of interconnectedness of policy decisions impacting mathematics education. And these policy decisions about general education impact mathematics education as well. So we cannot see mathematics education in isolation. It has to be what goes on about other general aspects of education as well. Now, many of the international bodies like UNESCO, the World Bank, okay, of an OECD, they have come up with a lot of projects, a lot of writings about education in the post-COVID world. For example, this one is from UNESCO, and they have provided these 9 ideas. I'm not going to read through the ideas, but you can get it from the website. But they are general, more about education, but certainly will impact on maths education as well. And my idea, and I concur with this opinion from UNESCO as well, is that some form of hybrid learning is what we are going to be left with. And this is perhaps the future that we are going to have, hybrid learning. How do you define hybrid learning? Hybrid learning is defined as a learning approach that combines both remote learning and in-person learning to improve student experience and ensure learning continuity. And there are 6 types that they have mentioned in this paper. And the hybrid model includes in-person learning. There is a homework model, a flipped classroom model, the synchronous live and in-person model with one remote simultaneously, asynchronous hybrid, or totally remote. And there are pros and cons for each one of these. I'm not going to dwell on this. But I'm going to use the perspective from the principles and standards of school mathematics. In particular, the principles. And these were written in the year 2000, and I find it quite relevant in the way we're going to look at the curriculum in the future. So I'll skip the content standards. Remember, there were content standards and there were process standards, 5 content, 5 processes. But I'm more interested in the principles. And these principles, there are 6 of them: the equity principle, the curriculum principle, the teaching principle, the learning principle, assessment, technology. And they fit in very nicely in the way we look at mathematics education for the future. And equity was also raised by the previous speaker, Dr. Wilkinson. And certainly all the other aspects are important. So let's look at each one of them. The equity principle. Certainly we want an equitable practice in a hybrid mode of learning. We would like to have it in general in the school system. So an important question for the field is how to prevent technology from reproducing or even widening the inequities in learning opportunities across groups of students. Under what conditions do these unwanted effects occur? So if there are inequities, okay, we don't have a perfect system in the schooling system. How can we prevent technology from widening the gap? Because not everybody has got technology, the right technology at home to use if we are totally in a remote learning situation. Sometimes there is only one computer in the house, or not at all. There may be only one handheld other device, okay, like maybe a smartphone. And how, in that situation, how can we be equitable? How can we make things equitable? And there's a lot of these kind of negative types of thoughts about things, all right? Coronavirus is like a blackout that has caught off the world of God in the elevator of inequality and the midst of globalization. So inequality is something that we need to look into very deeply if we want our students to benefit from the best maths education. Let us move to the curriculum principle. What does the curriculum principle state? It is more than a collection of activities. It must be focused, must be coherent, focused on important mathematics, and well articulated across the grade. Now, there are people saying this. What mathematics content should be taught today and prepare students for jobs of the future? What kind of mathematics do we need? Do we need the same mathematics that we have every day in the schools, or do we need a different kind of mathematics? Earlier, I suppose I didn't attend it, full of it, but Dr. Bartholomew presented his ideas about STEM, okay, how STEM ideas can be used. So the mathematics curriculum may be quite compromised in a hybrid learning situation. What may get attention is what is easier to teach in a hybrid learning situation. So there may be a trimming of the content. And this is not good for mathematics education. So we have to have a curriculum that is good enough. Maybe our intended curriculum hasn't changed because our syllabuses, our national goals and so on, our goals about teaching mathematics, these haven't changed. What is changing is the implemented curriculum, how it is going to be implemented. Because we no longer will have the normal classroom to implement it. Or maybe we will have it, we don't know. And this will certainly impact the attained curriculum by the students. What are the outcomes? So some responses go beyond interdisciplinarity, like what STEM proposes. and may even require some form of transdisciplinarity. Let's look at the teaching principle. Now, we would like to see, like in this picture, all right, student engaged with the teacher, all right, the teacher being there for the student doing group work. But effective teaching requires understanding what students know and need to learn, and then challenging and supporting them to learn it well. I like these statements from the McKinsey report in 2007. The quality of an educational system cannot exceed the quality of its teachers. The only way to improve outcome is to improve instruction. And achieving universally high outcomes is only possible by putting in place mechanisms to ensure that schools deliver high quality instruction to every child. So how do we use these principles in a hybrid learning context, particularly when we have remote learning involved in some form or the other? I am posing the questions, not quite giving the answers right now, but it is something to think about. Furthermore, the report added, you could define the entire task of a school system in this way. Its role is to ensure that when a teacher enters a classroom, he or she has the materials available, along with the knowledge, the capability, and the ambition to take one child to the standard today than she did yesterday, and again tomorrow. How does this happen in a hybrid mode of learning? So teachers also had to adapt to new pedagogical concepts and modes of delivery of teaching, for which they may not have been trained. Okay? No special training for many teachers. Just go out there and do some of the things that you were used to being in the classroom, do it online. If that online teaching is possible. So how can teaching be entertaining or engaging? How can it contribute to the broader educational goals? To contribute to students' developing students' identity, their empowerment, to see the value of mathematics. How does this happen in a hybrid learning environment? Now, the basic idea that we have is that the teacher has got clear ideas in his or her mind. In this case, this teacher has a clear idea about what is 2/3. But if you look at what the student has in his mind, is all jumbled, it's all over the place. So how do we make a congruence between the clear ideas of the teacher to these unclear ideas of the child? So there is a concern that the hurried adoption of new technology will lead to falling back to a pedagogy of transmission of knowledge. And we have to guard ourselves against doing that. Because transmission of knowledge is so much easier to do, all right, as compared to what we may be doing differently in the classroom. And some people have called it panic-gogy, panic for panic and panic pedagogy, but that's an opinion. And what about STEM? How to train mathematics teachers with solid foundation in mathematics, positive attitudes towards mathematics teaching and learning, and wide knowledge base linking to STEM. And just like we have frontline workers in the medical field, who have been there during this pandemic. So we would like to spare thought for the thousands of teachers who, with these impossible circumstances, are doing the level best to take care of the next generation, our children, for they are education's frontline workers. The learning principle. So we have teaching, now learning. We would like the smile on the face of this child, all right, to learn with a smile. Like these children, always with the books, looking at the books, reading and learning from it. So students must learn mathematics with understanding, actively building new knowledge from experience and prior knowledge. In particular, learners in most marginalized groups who don't have access to digital learning resources or lack the resilience and engagement to learn on their own are at a risk of falling behind. Because your engagement with learning is not the same when you are in a remote learning situation as compared to when you're in the classroom. And certainly the quality of learning might suffer as well. To achieve the goal of maximizing the quality of learning opportunities for every student, researchers and teachers must partner to conduct cycles of improvement that implement innovations. So here, partnering with researchers become more important because the amount of research we have for online teaching is very limited as compared to what we have for classroom teaching. And research is something that can be very powerful. Now, it is not really realistic to think that students can just show up and start taking classes at the same time every day in an online environment. And this idea of opportunity to learn was also raised by the previous speaker. Having the opportunity to learn does not equate to actually learning. The use you make of that opportunity to learn is dependent on what other opportunities you have in life. And the World Bank has come up with this idea about learning poverty, a bit similar to the concept of learning loss. And the pandemic is quite exaggerating, all right, in fact, exacerbating the number of students who are going into learning poverty. So out of 100 students in low-income countries in particular, right, out of 100 students, only about 37 are not in poverty, learning poverty. But imagine 63 of them being in learning poverty. So learning is an issue. The idea of learning loss has also come up in the literature. Because of learning loss will lead to skill loss, and skills people have relate to their productivity. Gross domestic product could be 1.5% lower on average for the remainder of the century. And this is terrible. Some more pessimistic views. Self-guided online learning is doomed to fail. Others simply have no incentive to keep at their studies without peer pressure. A teacher at hand or a structured, without peer pressure, a teacher at hand or a structural learning environment. And the role of parents and significant others becomes so important in this case. Since learners now mostly study at home, the role of parents in the education process becomes so important. In many instances, the parents are not really equipped to assist their children in their education. So perhaps we have to rethink how maybe the parents at home or the community or significant others in the community can be of help to children, to help them with their learning. The assessment principle. Assessment should support the learning of important mathematics and furnish useful information to both teachers and students. Again, how do we do it in a hybrid learning environment? What are the implications for formative assessment, for summative assessment? Chances are that what gets assessed is what is easy to assess in a hybrid learning mode. How do we assess student understanding? These are important questions that we need to kind of come to grasp with. And how do we assess students' affect and more generally the mental well-being? And this is very, very significant. If the student is going to sit down, okay, hour after hour following classes online, let's say if the online class is possible, it does affect the student. These are some general things about what to assess. I'm going to skip that. So the technology principle, and technology has to be there in the hybrid or remote learning mode, and it's perhaps the future of learning. So technology is essential in teaching and learning mathematics. It influences the mathematics that is taught and enhances students' learning. We have to consider technology perhaps in two ways. One, as a platform for teaching. By that platform, I mean, I don't know, okay, when I started using more of the platform for teaching, I was using Microsoft Teams, for example. Now I mostly use Zoom. But platforms for teaching is very important. What kind of platform do we need to use? But technology as a tool for teaching, which will not change. Okay, in mathematics, we use so many different kinds of software, all right? For example, all types of DGS, GSP, GeoGebra. So COVID-19 has forced institutions into using technology without the luxury of time to consider existing research or best practice. And this is something that we need to be doing more research in right now. How do we learn by using the different learning platforms? What are some of the issues? How can we best use them? So I'll go to some concluding remarks. And what I have are a lot of assumptions, hopefully. Hopefully the effects of COVID-19 will not be so extreme as to deny us our basic needs. And I have the confidence, on a positive note, that we will draft a curriculum that is reflective of the needs of the times and can be delivered both in an in-person mode or a hybrid mode. Because what we have right now is a curriculum that was meant for in-person mode being used in a hybrid mode. We will train teachers appropriately to meet the challenges of a hybrid and remote teaching. We will have the proper infrastructure for hybrid teaching. Schools are not well prepared. We will carry out appropriate monitoring of the system, and monitoring has to be done at various levels, at the school level, at the regional level, okay, at the district level, at the national level. We'll monitor students and teachers' mental health. And that's fundamental. We cannot do away with that, even if we're talking about mass education. We'll revise our expectations about student learning and bring about appropriate change in the formal assessments. Now, one thing has remained constant are the exams. What we are still doing in a remote learning mode is trying to prepare the students for the examinations that they are going to take, or the formal assessment they are going to have. So we should be looking into those kind of assessments, the formal types that we are doing. And beside the computer, we have to look at other devices, smartphones, tablets. How can we use them? because in a home, typically you may find one maybe computer, all right. There may be several smartphones. But if you have 2 or 3 people competing to use the same device, it's quite challenging. We will have assessment strategies in line with hybrid modes of learning. So examinations will have to be reassessed. And we need to transfer necessary funds to education. What has happened in many countries is that funds from education have been transferred to other sectors, particularly the health sector. We will share ideas and benchmark against best practices. We will put in extra effort to help the most disadvantaged children. And these are important things we need to think about because inequity can exacerbate the differences. We'll invest in research in mass education using a hybrid mode of delivery. And students will make good use of the opportunity to learn. So what may be ideal? Maybe something like this. Learners are prepared and motivated to learn. Teachers are effective and valued. Learning resources, including curricula, are diverse and of high quality. Schools are safe and inclusive places. Education systems are well managed. And that is in itself very important. Education systems are well managed. A lot of the decisions about education is not from the teachers, is not from school leaders. It's more from policymakers. How policymakers, what they decide about, okay, they can decide we are going to close all schools. They can decide, okay, we are going to reopen schools. Or we are going to open schools on 2 days a week or whatever. So ultimately, policymakers have an important role. And we cannot undermine this role. And of course, then you have the school leaders on top of that. To conclude, I will say this. Disruption on the scale we have just witnessed are not limited to pandemics, but may also result from natural, political, economic, and environmental disorder. So we have to be prepared that this may happen again. And we are still not out of COVID. But things like this can happen anytime. And now we should be having smarter ways of dealing with this situation or a similar situation. So in short, what I try to do is to paint a picture of mathematics education. There have been crises in mathematics education. We have tried to deal with them. But the current curriculum that we have to look at it very carefully and look at those 6 aspects that I mentioned earlier, all those principles. And there are ways into which we can look into the maths curriculum and reassess the mathematics education. And probably things are going to change, and forever we will not be teaching in the same way. So on that note, I say thank you for listening to me. And now I welcome your questions and comments.
Thank you very much, Associate Professor Jagut Singh, for your nice presentation. And we have a lot of information here. I think it's on best practice also from Singapore. And we have a question and answer session, Prof.
Yes.
We have already 2 questions. Let me share the question for you.
So I stop sharing here, yes.
Okay, so let me share for you, sir. Okay, for the first question, I disagree with Teams and PISA and Edge because it's only evaluate knowledge part. Can you give example evaluation for living skill of mathematics, please, Professor?
Oh, there is certainly, all right. When I mentioned about Teams and PISA, all right.
Yeah.
It's only because I said it was an issue. It created some kind of crisis in the world because people started to create what we call as league tables, like you have in football, for example, league tables. So this country is in top, so therefore, all right, we try to mimic what they are doing. And this is not a good thing. This is very bad. You cannot translate the curriculum from one country into another country because there are so many differences socially, culturally, all right? And certainly, I do not kind of try to promote that. It's not about Team and PISA have their importance. They try to compare, okay? They are international comparative studies. They have their value in that sense, but certainly not something for us to kind of mimic or use from the league tables. This nation is performing well, therefore we change our curriculum to fit the curriculum of that particular nation. That should not be done. So it's a good question, in fact. Thank you.
Yeah, thank you very much for your response, sir. And we move to the second question. May you give suggest how about the strategy of hybrid learning to make sure that we cannot get the learning loss?
I think if the principles that we have around that I mentioned, if they are all met, I'm sure that there will be less of a learning loss as compared to what we will do normally in the normal classroom. But the thing is that we have different levels of enforcement of hybrid learning in different places. In some countries schools are simply closed with no possibility of going to school. There is no technology available to be used. So in those countries, you certainly have issues. But hybrid learning, all right, has the potential because that's what we are probably going to do in one way or the other. And if those principles are met, all right, you have a strong curriculum, all right, but you have teachers who are well trained, all right, you have got technology that can be used appropriately, students are ready to learn, all right, you can assess in a proper way, then when all these conditions are met, I'm sure that this will be better. Certainly, there are certain good practices, all right? I am here in Singapore, and in Singapore, certainly because there was some preparation for the which was devoted to online learning. Teachers were told to anticipate this and to be ready to do that. And so this is not something new to Singapore. Right? Sorry, there is some interference.
Yeah.
Okay. So some countries were prepared for it. And therefore, I would say here, the transition from school teaching to a remote teaching, all right, was not so bad. I would say that maybe in some countries it was quite bad, or probably, but probably here it was smoother in that sense. There was some preparation for it. So I think if we prepare for it, and if we come in with more research, we are certainly going to have a hybrid mode of learning that will be more beneficial. But certainly as it is right now, it is going to meet with some teething problems because it is just starting, all right? And here we should differentiate with distance education. We're not talking about distance education here, but we are talking about hybrid mode of learning. So I have confidence that this is going to change and change for the better.
Right. Thank you, sir, for your response. And also we have two other questions.
Yes.
So let me show you. Well, the third question is, pandemic has changed how teachers should be teaching. And this is very new condition to us as a teacher, particularly mathematics teacher. My professor, Dindial, give us some tips and tricks so we can explore and role model in hybrid teaching.
Oh my God. I wish I had a bag of tricks, all right, of my it's difficult to say what will work and what will not work in a particular context. All right. Because socio-cultural contexts are so different. So what you have in, okay, maybe in your own local context, I don't know where you're from, maybe probably in Indonesia, or what we have here in Singapore may be quite totally different. But certainly there are certain fundamentals that cut across. That is, as a teacher, you are there willing to teach. And as a student, you have students who are willing to learn. And you have the platform in which you can transact it out, all right? Whether it is face-to-face or whether it is an online teaching platform. So essentially in mathematics, what are we teaching? We are teaching about concepts, we are teaching about techniques, we are teaching about results, okay? We are teaching about conventions, we are teaching about processes. So these are things that we are involved in teaching. So teaching will then require us to kind of put it in bite-sized pieces. In bite-sized pieces for the students to be able to assimilate it, all right? And this is not going to be easy. Bite-sized pieces is already hard in the classroom, in the regular classroom. But doing it now online in a remote learning situation could be quite challenging. So I acknowledge that. So the best thing I would say is that you try to use your best possible options available. Like I had to teach classes here at NIE online. So one of the things I found out, I needed to use a whiteboard at least to do part of the writing. And I didn't have anything to do because I was doing it from home. We were completely, in that case, locked out of coming to the office. So I was able to get from my drawer one white big piece, all right? And then I use it at the back to write. And I could use it, I was able to kind of, what would I say, all right? Able to use it as an ad hoc thing that I could use for teaching. So there are ways in which you can challenge yourself. For example, one of the things I also did was to create a WhatsApp group to contact my students very quickly, to give them samples of work I wanted to send to them very quickly. And I could chat with them very quickly through the WhatsApp rather than going through emails and other possibilities. So I don't know how it's going to work for you, but I think the best advice is that just try to do your best, all right, in the online platform, and try to learn from other practices, how other people have been doing it elsewhere. And this means that we need to be open to ideas coming from outside the country. And like this is a good platform to learn from how other people are doing things elsewhere and share the ideas and then improve on our teaching. Now, let me look at the next question.
Yeah.
What are the specific indicators of learning loss as impact? And what are the strategies to overcome this? Now, I do not have the exact way in which it is measured, but if you want to read the whole document, it is available, all right, from UNESCO and from the World Bank. You can refer to those readings over there. So learning loss is, as far as I know, is okay. What probably is different from what you do in a normal classroom situation as compared to what you would have done, okay, what you're doing right now in hybrid mode or remote learning mode, all right? Certainly, whenever we teach, not everything that we teach get learned. So remember what I said, the intended, the implemented, and the attained curriculum. So what gets attained is a very small amount. Okay, when you intend so many things, as things trickle down, the amount attained is much less. So in a hybrid mode learning situation, this becomes even lesser because the engagement of your student is not quite the same. Your kind of formative assessment is not quite the same because you cannot monitor what the student is actually doing and writing down. And therefore, certainly there are issues over there in the way you're going to teach. So learning loss will happen. It is normal that it's going to occur. And what we try to do is always try to minimize it. We cannot eliminate it, I suppose. I don't think we can eliminate it, but we will have to minimize it. And minimizing means trying to use optimally all the resources at our hand to make the student learn better. That's the best advice I can have on this one.
Thank you very much, Professor, for your advices. And I think it is the last question. Professor, let me ask you, because I was wondering how Singapore, particularly in Ministry of Education, like doing mathematical learning, such as, is there any reduced competency? Because in curriculum, we have a lot of competency, for instance, for senior high school, or maybe for primary school, they have a lot of competency. When during the pandemic, is there any reduce of the competency because we have a lot of limitation and in learning processes?
Oh, by competency, you mean part of the curriculum, I suppose?
Yeah.
I don't think so.
Mm.
What happened here is that the content for the teaching was not changed. The content remained the same. Okay, what had to be taught in school, all schools have got a scheme of work based on the syllabus that they have from the ministry. And that content remained the same practically. And the exams didn't change. The formal exam like PSLE didn't change, all right? So teaching had still to be done in a normal way about the normal content that was supposed to be done in the classroom situation. So there was no change, in fact, in the content to be taught. Simply what changed was the delivery mode, that it was done online. All right, that was the thing that changed. So here it is called HBL, home-based learning. So it was home-based learning for the students. And except for a couple of students who were the children of frontline workers, they were allowed to go to school and teachers could teach them directly. But most of the students were at home, all right? And during the complete closure, I mean, all right? So in that situation, no, there was no change in the content. The content would remain the same because as I said, there was some anticipation about this sort of thing happening. And therefore, a little at least, okay, Singapore was prepared about how to do it online.
Right, thank you, Professor, for your response and for the information about the best practice in Singapore, and also you have response all questions. So now let me read the summary of your talk. So all distinguished lecturer and teacher and students experience a lot of challenges in learning process during pandemic, but we can overcome by using our strategies and also our experiences. And hybrid learning is expected as the solution in today's learning. So there are 6 types of hybrid models. The first is in person. The second one is homework model, instruction at school, practice at home. The third is flipped classroom. It will be my favorite type, sir, actually in my classroom, flipped classroom. And then the fourth is synchronous live, 5 asynchronous hybrid, and the last one 6 remote. And also, we know that the principle of school mathematics by NCTM 2000, the equity, curriculum, teaching, learning, assessment, and technology. I think enough for this session. Associate Professor Jagut Singh, thank you very much for your interesting and wonderful presentation. And thank you for your participation. Maybe you want to give your closing statement, sir?
Okay, I did have in my slides, let me see.
Yeah.
I did have, can you see my slides now?
Yes, I can see.
I did have some demographics of the region and so on, and I wanted to talk a bit, but I didn't have time about it to talk about this. I think this region, the ASEAN region, is quite important. And so if you look at the Human Development Index, is quite high for Singapore, Brunei, Malaysia, and high as well for Thailand, Indonesia, Philippines, and Vietnam. All right, so it's a region which values education, because in a 642 million that we have people around here. I'll take 1 or 2 minutes, is that okay? So you have a high literacy rate, so education is valued a lot in the region. And if you look at the literacy rate here is as high as 96.8, is on generally about 95% of the adult population. Some characterization that we have of this here is content driven, exam driven, more focused, all right? This is more from the East Asian perspective rather than the ASEAN perspective, but I think a lot of this is also true for this region. So you can read it on the slides. And if you compare between East and West, you look at, these are some of the characterization that we will have. And except for the last one, Chinese language, all right, the rest are also, I think, applicable a lot to this region. So I would say that no specific things about this region. There's nothing wrong, I think. Everything, there is a lot of value in education. And I think education is going to find a way to go back to the normal. And even if it is a new normal with hybrid learning, I think that the region is going to do fairly well, or quite well, if not. So thank you very much.
Thank you very much, Associate Professor Jagut Singh Dindyal, for your information, nice information. So please give big applause for Associate Professor Jagut Singh Dindyal or Professor Daya. Thank you so much, sir. Thank you, everyone. So I return to Ms. Hani Palupi.
Thank you, Mr. Subhan. Thank you. Thank you very much, Mr. Subhan, for chairing the session of Associate Professor Jagut Singh Dindyal. And it was amazing presentation and discussion. Participants, please round of applause and thank you. Ladies and gentlemen, we have come to the end of the international webinar, Preparing for a Post-Pandemic, Shaping the Future of Mathematics Education. Before I close the program, I have several announcements for participants. The e-certificate will only be given to those who are eligible and will send to your registered email. Kindly check within a week ahead. Kindly fill the evaluation form of this webinar to make some improvement for Sikkim in the next webinar. Thank you very much for participation who joined the giveaway and we will announce the winners soon on Instagram feed. Once again, let me conclude by saying thank you to all prominent keynote speakers and moderators, Dr. Scott Bartholomew, Professor Trena L. Wilkinson, Associate Professor Jagusting Dintial, Professor Edward M. Brief, Ms. Maria Suci Apriani, and Mr. Subhan Aziz Awaludin. And thank you for esteemed participants. Hope to see you again at the 2022 second international webinar. Stay safe, stay healthy, and stay happy. See you. Good afternoon, and wassalamualaikum warahmatullahi wabarakatuh.
Thank you all.
Thank you, Professor. Thank you, Prof. Serena.
See you here.
Farida.
Yeah, thank you, Mr. Subhan.
You're welcome, Doctor.
Thank you, Professor Trena.
Thank you all.